Thank you, Mr. Zeng. And our next speaker, again, we are jumping around the world, is Julian Hoffmann from the ETH Zurich. And they had a program for a fuel cell general aviation aircraft, which they could release in a very fast time. So we hear about how they could do this. Julian, stage is yours.
Well, thank you very much. Yes, I am Julian, and I am part of Celsius, and we are a student association. So we are part of ETH, and what we have developed in the last 3 years is this airplane, the H2 Sling, which I'll touch upon a little bit later. First, who are we? We are students from ETH who do such a project as this on their sites for a year or two, and the association in itself has 3 main goals. First, as we are students, we want to build like a network of alumni, which could be interesting for industry and partners because we have a lot of talent, we have a lot of people who are well known and which know what they should want to do in aerospace. Also, our goal is to develop sustainable powertrains for aviation, and this is what we do since 2020. Then, with the addition of 10 focus students each year, this is 10 students which come to the team each year, we grow steadily, and with this we can always tackle new projects. And this is what we have done in the last few years. In the beginning, 2020, we started with the e-Sling project. The e-Sling project is a pure electric project, which we have developed in 2 years, and which has flown back in 2022, and was a major success for us. Then, parallel, we started our H2 project, as the name suggests, using hydrogen. Then, we have done a concept study and have now, in the 3 years, pretty much developed the whole airplane, the whole powertrain, and now are close to maiden flight. Maiden flight is planned for later on, the beginning of next year, in April, so we are not far away. And we have also started, in September this year, our newest project, liquid hydrogen. So we are steadily developing, and now we want to make the switch to liquid hydrogen. First, about the e-Sling. This is our plane, which has flown in Switzerland and is still flying, and it has been a major success. We have been flying it for now 3 years. We have also been to Aero Friedrichshafen, so we have flown it all the way to Germany, and it's just our way to say, well, electric aviation is possible, even as students, so it's a good way to go. But we also saw that, yeah, the recharging times are quite long, so we want something that's faster to recharge and something that can fly a little bit further. So that's why we switched to a hydrogen-based approach using a fuel cell. So what we do is we use a fuel cell to generate electricity and then have a battery which can store the excess amount, or also during takeoff help the motor out and give a little bit more energy. And we have around 5.2 kilograms of gaseous hydrogen in the airplane, which is not a lot comparing to normal aircraft, but it's enough for around 2 hours of flight. And the main point is that we have 0 emissions. That's what we always want to achieve. So that's why we went for it. The base model for this is a sling. As with the other project, the e-Sling, we use an airframe from Sling aircraft from South Africa, because we as students do not want to modify the aircraft too much in the aerodynamic sense, because then the whole certification process would just be much harder. So we focus on the powertrain and leave the aerodynamics to other company. What are the goals of our project? Our goals is, as we are students, we want to build the first student-built hydrogen airplane in the world, and to make history with that. Also, as we are in Switzerland, we have a lot of mountains, beautiful mountains, and we want to cross them. And this is why our main goal, our main flight we want to achieve later on, is flying over the Swiss Alps and showing that it is possible to fly emission-free also over the Swiss Alps. And now I want to tell you a little bit, how do we build our airplane? because we as students maybe have a different approach, and we also want to do a hands-on approach. This is our fuel cell system with all the different parts and stuff you need. And first on, as every team, we have designed it in CAD models and had to get our heads around how we can even build it. Then we got it in the hangar. We put everything together. It looks a little bit messy in this picture. Trust me, it's not as messy as it is there right now. This is the first prototype where we just put everything together, some cables there and there where it shouldn't be, but it works, and it was the proof that we can run a powertrain system successfully. Then once installed, it's behind the pilot, so we have the pilot and co-pilot in the front. Then we have a little wall, and there would originally, from the Sling High Wing, you'd have 2 seats in the back, but we removed them and used them for a fuel cell system. Because of the CG, we need to remove the passengers behind, but it's still a good concept. Also, we develop our own electric motor. So what we develop is the mechanical heating part, so like how you can cool it. And we have a partner company, E&H. E&H, they are also based in Switzerland, and they help us develop our motor. So we have a custom motor for our application, which is perfect for what we need. The same with the inverter. We also develop our inverter in-house, which is always a great challenge and a great learning for the students. This inverter is now the 2nd generation. As with the motor, the first one was used for e-Sling, and then we improved it. And now we have an inverter for our H2 Sling, which goes to show that we are developing in every way possible, improving in every way possible, which we can. Also the battery, we also do them ourselves. We buy the cells, we develop our own structure. Also we have a BMS, which we use. And with this, we also can choose the form factor for our battery, which is really important. Because if we compare in the e-Sling, the electric project, we had batteries in the leading edge of the wing. And now we only have a small battery in the airplane, which is in the front in the motor compartment. So you also need a different form factor, different application. Here we need faster, more power and less energy density. So that's why we go this way. This is also the same picture, doing the battery, putting it together. And then also one big point is for us the cockpit. There aren't that many hydrogen-powered planes around, so there isn't a standard you could use to say for the pilot what does he need to see and what doesn't he need. So we also have to do our own things. So on the left you see a normal avionics display, but on the right you see our own custom powertrain display, which we developed in-house, and also had to think about the questions, what does the pilot even need to see? Because the less he needs to see, the better. He has to fly a plane. In comparison, when we tested the powertrain on the ground, we had about 5 people in the testing container to overview and just be there for safety reasons. But in the aircraft during flight, you just have a pilot who looks on the screen when he has time, but not that often. So yeah, it was a big challenge. In the end, we made it work, that it's really clean, really tight, and it's all looking really good, and the pilot does understand it without having to really look at it that much. And with that, we have like the whole powertrain. As I said, the airframe we just buy, so we shouldn't do that much of modifications. But sadly, we have to use hydrogen tanks, which do not fit well in the original airframe, so we need to do some custom parts for our tanks. So these are some mechanical parts we also developed, also designed, and then also some carbon fiber, glass fiber parts we do for fairings. And with that, we have our final plane ready. Not just as a model in here, one part also, when we have the final plane, we also need to do it to get it certified. This is always a big part. We are here in contact with our federal administration, the FOCA in Switzerland, and there it's also a challenge because we are the first hydrogen-powered aircraft in Switzerland, so we also have to design with them what the rules should be, which is also a great challenge, but also we are honored to be able to do this as students with them, and we are on a great process now. We're almost at the finish line, only a little bit of documents which are missing, and with that, we have our final plane. This is the plane as we have revealed it in end of October this year in Switzerland. And it's really a great plane. It works. We have tested it on the ground. We can do taxi tests. We can do full power. So basically everything we tested besides flying it, because we are missing the permit to fly. And yeah, some little facts I told them earlier. So the maiden flight is planned for April next year. We will plan to fly around 2 hours, which should be possible. And with this, we get a range of about 400 kilometers. Yes. And that's it from my side. I hope you enjoyed it, and thank you very much.
Thank you very much, Julian. Well, we'd like to highly appraise this project. This is a student project. You dare to challenge yourself, and it's a hydrogen-fueled aircraft. Mr. Zhang from CSAA just sat next to me earlier on. We also encourage our Chinese students to initiate and be part of this project. We also have such a student competition organized in China, and we encourage Chinese students and international students to be part of this competition, because innovation requires joint efforts and relies on the young generation. We'd like to have more young people joining this course. Next, we'd like to invite Mr. Zhang Yuegang, an old friend of us from Monta Vista Energy Technologies Corporation, and he's going to talk about high power and high energy density batteries for Zhongsan eVTOL. Welcome, Mr. Zhang.
Okay. Actually, I'm also very impressed by the presentation of Julian, and I also, if possible, I would like to invite you to Tsinghua University and give a talk to my students. So I hope you can encourage them to more get involved in doing real things, spending time doing real things, not just get concerned about their GDP, GPA. So. Yeah, I would like to host you if you like, and your team, certainly. Yeah. Okay, back to, actually, my presentation is related to your power system, especially e-Slim, just talked about. Certainly, hybrid also need batteries. So battery for electrical aircraft, that's a must. And our company actually is trying to produce the battery of highest energy density. But certainly now we have this application like eVTOL. They not only high energy density, they also need high power. Okay, so today, not only high power density, also talk about how what's the level of power we can handle in our batteries. And certainly you on the program, you only see my title as a founder of Monta Vista Energy. That's our company. I'm also professor in the physics department in Tsinghua University. So, right, so I like to work with young guys, okay? If we look at the application, not batteries are useful for the future, almost everything, especially for transportation, if we want to avoid the use of the fossil fuel, okay? And the basic requirement, the first certainly is safety. The second, actually, The second is the most important indicator that has driven the development of battery technology. It's like a battery field. In battery field, it's like a Moore's law in semiconductor field. Okay, so I'll start to talk about high energy density. What we use to increase the energy density. This element is the lightest solid on Earth. I'm not talking about the gas phase or hydrogen, okay? Solid phase. And it's very reactive. It's electrochemically active. So it's very good for battery anode. It has a very low electrochemical potential. Its lowest electrochemical potential. That means you can provide the highest voltage for your battery system. Okay, other anode cannot compete with that. Okay, and it's not new. You know, every good things, a lot of people thought about it before. The Nobel laureates, two of them actually used lithium metal as an anode. They demonstrate how lithium can store energy, electrochemical energy efficiently. And later, people found it's hard to commercialize it because the lithium, when you charge, the lithium plate should plate smoothly on your anode surface, but it didn't. So instead, they produced this sharp tree-like structure that will short your cell. That's why in the 80s, you know, a lot of companies tried to commercialize this lithium metal battery, but they failed due to the short circuit, and that caused the heating and the explosion. But later, you know, Sony and certainly Yoshino Sensei, and they discovered this carbon-like graphite anode that make our battery safer at that time, okay? But the cost is that they had relatively low energy density. All right, so to solve this dendrite growth short circuit problem, people sort of say, lithium is soft. If we have a very hard electrolyte instead of a liquid, they may block the dendrite growth. That's why in the past 30 years, actually people try to find good solid electrolyte. Actually, solid electrolyte existing for many years, already commercialized. That's in the thin film form. Lithium, phosphor, oxygen, nitrogen, this kind of amorphous structure, but it doesn't work for large format batteries. But recently, people find a lot of high ionic conductivity material like sulfur-based and oxide-based. This is a demonstration in my lab in Tsinghua University. Unfortunately, currently, all solid electrolyte could not prevent dendrite growth. Okay, so it's a disappointment, but we are still working on find a new material can really block it. Okay, so if the solid electrolyte cannot block dendrite growth, that means it cannot be used for lithium metal battery. What can we do? So we use the electron microscopy to see how this dendrite grows in liquid cell. Previous slide, I just showed how the dendrite grow in solid cell, solid battery. Here's in liquid battery. Since solid battery, I cannot use lithium metal, we still use liquid. Why? Because from this one, actually, I'm not sure I can replay the video. here, if you look carefully, there are a lot of black dot is growing. That dendrite grow very fast in a normal electrolyte. But if I change the electrolyte, okay, you see it grows slower, and for that composition, almost no dendrite can grow up. It grows very short dendrite. Why? Because we add a lot of additives. Those additives can suppress the growth of dendrite and make our cells safer. That's the advantage of a liquid electrolyte. Solid electrolyte is very hard to put functional material in your electrolyte material. It's solid. It's very hard. You need to design a new material to do everything. But a liquid, we can have different components, different molecules can play different roles in your liquid electrolyte. There's more actually advantage I'll talk about later for the electrode structure construction. Okay, you got the idea. We could easily find some molecules can prevent dendrite growth. Okay, if you need more, you can read my paper. Okay, and here's now our company just design new electrolyte to make it work. Fortunately, it works pretty well. Not ideal yet, we're still optimizing it. Pretty well means we have a new electrolyte, make the growth very smooth, relatively smooth than the lithium. And we can have safe operation. Okay, it can pass like a nail penetration in 2019. That's several years ago. Even the lithium-ion battery at that time, if you use the ternary oxide cathodes, high nickel concentration, those cathodes, they could not pass the nail penetration test. But our system at that time, we passed the nail penetration test. So that actually make our very confident lithium metal can be used if you design that properly. The safety issue can be addressed. Okay, so certainly recently we used one of our customers' flight profile eVTOL. We can demonstrate our cell. If you control the use condition, it can also cycle many times, like close to 1,800 cycles. Well, certainly it's a shorter range flight profile. If you have a long range, in the future, we have to decide how much capacity you want to use. All right, so high power. I talk about the eVTOL. High power, the problem is a lot of cells can do high rate discharge, but the temperature rise is significant. For example, here we compare the blue is the lithium metal cell, our product. And we compare to the gray ones. Gray ones are silicon-based lithium-ion battery. The temperature we can, at 10 C, we can control it very nicely below 1700 Celsius. And the silicon cannot. It reach like 80 degrees Celsius. Okay, that's one thing. The other thing is at this high specific power, like close to 3,400 watt per kilogram, depends on how much kilogram you need, right? So it's very high power density. Under this power density, actually, if you only leave like 20% of emergency power energy, you can survive. It will last like more than 3 minutes. Like normally, I think it could be enough for you have an emergency landing. Okay, that's our high power cell, the capacity of our high power cell. So now we have a automatic production line in Hefei. We have a plant can mass produce. It's not a large quantity because, you know, you guys, you need to make your airplanes like more large quantity so we can get a large quantity production. But it's good enough for testing. We have capacity production like 200 megawatt per year. So that's a good automatic line. It's I believe it's the first in the first one. And certainly we have this high power series, high energy density. High energy density is over 500 watt hour per kilogram. In the lab, actually, if you don't care about cycling, we can reach like 760 watt hour per kilogram. That's in the lab, okay? So we are in the stage where coming back to the lithium metal, what I call it Back to the Future, this older American movie, a scientific fiction movie, okay? And with that, we see the roadmap. That's a roadmap I used many times since like 2010, 2009. And we see this light blue is a lithium-ion battery. It can reach around 400, then it will saturate because the theoretical limit will be reached. And the red curve is our current lithium metal battery. We still use oxide, high nickel, this transition metal cathode. And it will reach, at a certain time, reach about 600. In the lab, I said it's 700. Maybe that's the maximum, okay? In the future, we still need higher energy density. How can we do? Lithium metal is already reached the limit. It's the ultimate solution for anode. But on the cathode side, we still have several options we can go. That's my favorite topic, is the lithium sulfur. We just use the elemental sulfur as a cathode, pair with the lithium metal. Well, lithium sulfur, they don't have lithium, so you have to use lithium metal to supply lithium. Okay, it's different from lithium-ion battery. So now we are working on all solid-state lithium sulfur battery in my lab in Chong'an University. We got a nice progress because I have been working on lithium sulfur for more than 15 years, okay? Now finally, we got some good results. Our old result is on liquid. We find some problem we called polysulfide shortening. That's a different problem with dendrite growth, okay? But unfortunately, dendrite growth is still a potential problem in the system because, as I said, all solid resolve the problem of this polysulfide shortening, but it won't resolve the dendrite penetration, as I showed before. Okay, we're still working on that. So in the future, if we use a next generation of oxide cathode, like lithium-rich layered oxide, and we can reach about 800 watt-hour per kilogram in the next few years. I think it's highly possible. And another maybe 5 or 10 years, our lithium sulfur, I think, could be ready for the market. At that time, the limit could be 1,000 watt-hour per kilogram. That's possible. Beyond that, let's hope, get our finger crossed. We'll stop at 1,200 or 1,500. the theoretical for lithium sulfur is 1600 something. Okay, but you will never reach the theoretical, right? Okay, so let's hope that. Well, around 1,000 watt-hour per kilogram, I think our intermediate range, like 1,000-mile flight, may be possible with a larger airplane, electrical aircraft. Okay, that's it. We certainly also concerned about the more control of the safety issue, but that's what we are doing right now, system level, okay? So I think, yeah, Willi stand up, so I got a presentation too long. Hope for my information helpful to you. Certainly we also have a booth. If you need more information, you can just get outside and see our product. Okay, thank you very much.
No, thank you, Professor. And yes, we are always interested. We had you at Aero, we have you here, but we also always have a tight schedule, but it's fine. So our next speaker is, I got the wrong page here, I was wondering. Our next speaker is Christian Mundikler from e-Aviation, and we are coming to another field of propulsion system energy, because we've seen that hybrid, at the moment, a lot of people looking at hybrid as they see, okay, people want long distance now. They want to start now, and for this we need probably hybrid systems. And Christian, working for a company which is producing combustion engines and hybrid propulsion systems which could deliver high power at low consumption, as I understand, right? Christian, stage is yours.
Good morning, ladies and gentlemen. Willi, thank you for the invitation. I'm very honored. I know Willi since 2007 when I joined Rotax, and I can remember that we sat together in 2011 in Oshkosh talking with Greg Bowles, at that time responsible for the FAA. And Greg Bowles asked the industry, yeah, we want to make new rules for electric aviation. Please tell us what you need, dear industry. So now, so many years later, we are here, and congratulations also to Mr. Goshin for organizing this event. So this is really amazing. I'm really honored to be here. Thank you again for the invitation. So Christian Mundikler, I joined Red Aircraft July last year, coming from FACC. I was responsible at FACC for aftermarket and eVTOL business, so I was involved also in the Arch and EHang project, but on the composite side. Originally coming from Rotax, and in Rotax I started already hybrid projects also with Diamond and Tecnam and Rolls-Royce. You can Google the H3PS project, a parallel scalable hybrid project. And therefore I'm pushing also at Red Aircraft the hybrid propulsion and hybrid generator projects. And we have several projects, and I want to show you in a minute. I have summarized on a two-pager whatever I show you. You can come and I will give it to you. So we are producing hybrid generator units customized up to 380 kilowatt at 800 volt DC. So the picture here is just a rendering. We cannot show you the current customer projects due to NDA, of course. Red Aircraft is based in Germany at the Nürburgring. So if you are a Formula One guy, come to the Nürburgring. We are at the racetrack. All our employees are somehow related in racing. The company itself exists now 30 years because it was founded in 1995, developing racing engines, but since 2008 purely focusing on aviation engine. And this engine, I say it up front, the V12 red A03 is not a car engine. It's an aviation engine from the very beginning. And yes, our engine is type certified, because whenever I talk about our engine, the first question is it certified? Yes, since 2014, it's certified, and you can see the several validations from EASA, FAA, CAA in New Zealand, also MAC in Russia, and Transport Canada will be finished by end of the year. So Red Aircraft is a growing company. We are now 40 people, and we are currently hiring 2 people per month. But more than 2 we cannot train. So this is the maximum which makes sense. Just to show you where our engines are used in the agricultural utility planes, for crop dusting, but also for skydiving. So you see here an air tractor and also a Fletcher. On the white one is the Fletcher in New Zealand, and the yellow one is the air tractor in the United States. But the main business is in South America for crop dusting. Then also the commuter aircraft, the Beaver, was presented yesterday, for example, for seaplanes. And there are 1,600 Beavers out to be converted, potentially with our engine globally. OEM project Celera is also public knowledge in the States, from Auto Aviation. They tested our engine with 50% blend of SAF. We are now testing our engine with the University of Kaiserslautern with a 100% blend of SAF. You probably know also the Eco Caravan produced from Ampere. So we cannot talk what they have in the future because of our NDA. You will see publications very soon. They use an electric engine in front of our combustion engine to boost the power up to 800 horsepower. And they can extend the range nearly to double. So this is really amazing and very, very fuel efficient. So coming to our engines, we have the V12. Red Aircraft is the home of the V12 in 500 and 550 horsepower. And you can see the 4 versions with the utility gearbox, with the aerobatic gearbox for high altitude, and for helicopters without gearbox, which is the base for our generator unit here on the right side, highlighted in orange. Again, the engine is designed for aviation from the very beginning, highly integrated, meaning there's a heat exchanger for the oil, for the gearbox oil and engine oil within the V of the engine. So the OEM only needs to take care of the coolant radiators, but not for radiators of the oil. Everything is integrated. It's type certified, I mentioned it already, for jet fuel, but also for sustainable aviation fuel. We have experience in parallel and serial hybrid and in APUs, and we want to go into this business. It's also foreseen already for downsizing from the V12 to V8, V6 and i4. So going down from 500 horsepower to 400, 300 and 200, which means then on the electric side 140 kilowatt. Down to that level we want to go in the future. We have single lever operation, fully redundant, so each bank can run on its own, has its own supply with charging air, with a high pressure fuel pump, with coolant, and also with the oil circuit is completely separated between the 2 banks. The production, 90% in-house. It's a mainly German engine. Only 1 casting is coming from UK, but also the FADEC is produced in Germany and the IP is owned by Red Aircraft. So we developed the software and everything is in-house. So this is very good when it comes to export restrictions. We are not dual use and so on. So we have complete independency and complete freedom where to ship. And again, it's certified according to EASA. More details to the FADEC, DAL B, so Design Assurance Level B, is quite a high safety standard, fully redundant, 2 computers in 1 box. Each is checking always the health of the engine and each could take over if necessary. It's certified for the CS-23, but also small helicopters 27 and big helicopters 29, as we have also applications there. And it has initial built-in test and a continuous built-in test. And via the CAN bus, you can monitor the healthiness of the engine. And we have a maintenance tool to read out all the data. And what is important for the APU business or generator business, we have a bidirectional serial connection RS or interface RS485. So you can control the power, the needed power from the engine via the FADEC and the serial interface 485. And by the way, it's also used for the drone applications to communicate with our FADEC. Here you see a picture, a more realistic one. We changed it a little bit from a current customer project. So we have applications in hybrid electric gensets, eVTOLs and electric aircraft, as well as auxiliary power units. Of course, it's a diesel cycle engine, as mentioned before, with a very high safety level. It's turbocharged, dry sump oil lubrication, and it's self-carrying structure, so cantilever mount only on one side, no bed mount needed. And it's designed for lean maintenance, which means low cost. So every 100 hours, you change the engine oil, that's it. Visual inspection, and that's it, up to 2,000 hours. Nothing else to do. So we have various configurations, depends on the customer needs, with or without gearbox, with one generator, with two or with three generators on one shaft. And therefore, also the length of the system varies. The longest one is 1,287 millimeter, using a planetary gearbox and a high revving generator in the front. So you see here the peak power, 383 kilowatt, when the engine is running on 4,000 RPM, like for the takeoff, 405 kilowatt. And then max continuous power is 327 kilowatt at 3,750 RPM. I think what is gorgeous here, the 218 gram per watt hour or kilowatt hour, very high fuel efficiency, brake specific fuel fuel consumption, 218 gram per kilowatt hours. This means, for example, for max continuous power, 77 kilogram per hour, which is 40% less than a turbine, if you compare it with a turbine. And as mentioned, the dotted line, we also have high altitude applications. Then we use not 2 turbochargers, but 4 turbochargers, 2 turbocharger stages. So system weight is 350 kilogram. This is the lightest one. Dry weight of the engine without gearbox, 290 kilogram plus 60 kilogram of the entire electric system, including gearbox. This is the lowest number we can reach. This means we have a power to weight ratio of 1.1 using those numbers. I think this is clear. Everything is included: FADEC, electric looms, exhaust system and turbochargers, generators and inverters, integrated cooling systems. Optional, you can order air duct, radiator, intercooler in an installation kit. So we want to offer not only engines and spare parts, but the joint development. We help with supplier selection. We are not married with any electric supplier. It's up to the customer to choose their right partner. And we support with engineering, with 3D data, compliance showing, and of course documentation. So we provide 3D data of the engine and of the system to accelerate the design in. And when you compare it to the turbine products, we burn less fuel, up to 40% less, as mentioned, meaning also less CO2, up to minus 40%, and less noise, much less noise. And this is a new requirement, especially from airlines, to reduce noise at airports. So it's very interesting APU business in the future with our piston engine. So lower purchase costs compared to the turbine, lower maintenance costs, and also lower operating costs. In a summary, this is my last page. We are developing hybrid generator units customized according to the customer's needs. And we have significant projects under contract or committed by LOI or Memorandum of Understanding. And Red Aircraft is in contact with all major generator and inverter suppliers. And the Red A03-300 for generator units was in our program from the very beginning. And you see some more pictures from each side. Thanks for your attention and waiting your questions later on.
Thank you, Christian. Excellent presentation. So from yesterday to today, we've seen lots of new developments of eVTOL and electric aircraft. Power is an important part and also a challenge. The academic circle and the industry are also both trying to figure out the solutions, and we can see this area is progressing rapidly. Next, we'd like to invite Professor Qian Yuping from Tsinghua University, and he's going to talk about ground effect on the flow stability of the ducted fan propulsion system in flying cars. Quite a professional and a long name title. Welcome. Hello, good morning. It's my second time here, and I'm very happy to be here. Last time, I talked about the integrated design of ducted fan propulsion system, and this time, I'm bringing you the update. We've done some commercialization thanks to the support of partners. In 2025, flying cars have been transformed from a concept to a reality. So our work has altered our focus from concept verification to safety assessment. We want to study the ground effect and other impact elements on the flow stability of ducted fan propulsion system in flying cars. I'll mainly cover 4 aspects. First of all, the background and the definition. Well, flying cars are gaining more popularity because aircrafts, which used to be a commercial large vehicle, can now be converted into something that is personal and something that everyone can own. And the definition of a flying car is electric vertical takeoff and landing aircraft oriented to mass low-altitude transportation. That's a pre-assumption, mass low-altitude transportation. So based on that definition, we can divide flying cars into 3 categories. The first one is e-Hang and auto-flight and aerorefugia vehicles, those that could only fly in the sky. And second is Xiaopeng and GAC air car, with flying cars with separated structures. They integrate on the same platform. And the third is the bottom right picture, which could drive on the road and fly in the car. It's an amphibious vehicle. So, the first bottleneck of flying cars we now encounter is payload and range. Second is safety, and third is road-air compatibility. So, my presentation will mainly focus on safety today, because safety is the #1 priority for cars and flying vehicles. Right now, flying cars are mainly driven by new energy propulsion system, and the main concern of new energy is battery and battery explosion. That may involve electrical, thermal, and hydrogen problems. Also, this may involve the design of the battery and also the flying safety. According to the U.S. helicopter safety team, the helicopter crash rate is about 4 crashes per 100,000 flight hours. That's the figure in the traditional segment. So, if this figure continue to exist, then we will see significant urban safety problems once such low-altitude aircrafts are deployed in the cities.
In terms of the duct fans, aero car, we can find some advantages, for instance, high specific thrust, low noise, and high safety, mainly illustrated in the high-speed propeller. There could be the deducted fans, and to cover as a shell, there is additional propulsion. But in the process of takeoff and landing, there is a major issue. To start with, there is the side wind, and also we cannot avoid the ground effect. We may see from the takeoff of this aircraft that when the side wind and the ground effect are combined, once there is the instability in the flowing of the blade and the fluctuation in terms of propulsion, accidents are more prone to take place. So the core is that the flow inside has major changes. If we change from the suspension wing to the ducted fan, because the restraint from the fan is stronger, because the shell will restrict the airflow to go from the sideways. That is quite different from traditional method. For ducted fan air car, we need to pay more attention to the stability of flow. As a result, we proposed an idea based on the distributed electric propulsion. There is a sensing, the decision, and the prediction for the propulsion so that we can effectively operate the flight control. In terms of sensing and decision, we hope to introduce the AI algorithm. By the training of the data in the lab for the complicated instability in flow, we can make it into the data model that can be fast commissioned or caught by the flight control system. In terms of flight stability, in the past, we mainly relied on physical modeling. There are two methods. To start with, based on experiments, we can realize the propulsion modification and prediction. For instance, there is a Tisman and the core model. We can make the prediction on propulsion on different heights. But to the height very near to the ground, the formula will fail. The reason is that in this range, the flow may be less stable, the disturbance will be strong. In terms of stability prediction in that region, we now have the theoretical model and the data configuration simulation, but it's mainly based on the experience and the physical modeling, which is far lower than the standard of flight control. In recent years, with the AI algorithms, in particular computer learning, many universities are developing the AI, the machine learning, and the proportional modeling to combine them all so that based on the small aircraft, we can make some application. For instance, it includes the AI, machine learning, so that in complicated meteorological conditions, in particular strong side wind, there is a tracking of flight trajectory. So the physical plus data fusion, the method based on physical patterns, plus the data, the neural network modeling based on the complicated scenario, we can have the more effective method in ensuring the operation safety. In comparison, traditional physical model cannot meet the requirements of the flight control in the future, because in the least workload and study only, that is for physical, but narrowly validated, because for many factors it oversimplified the parameters. If we only use a data modeling, they can have the precise and for specific tasks data demanding and poor generalization. So now for the physical data fusion method, it is potentially suitable for more precise and real-time model fulfilling flight control demands to get more precise generalization. Based on the environmental disturbances, can be categorized into the 5 types. The first one is the side wind. For instance, for wind and takeoff and landing, and also for the ground effect. On the ground, there can be some like ceiling effect or sidewall effect based on different dimensions of aircraft. Today, we mainly talk about for the air car during the takeoff and landing, there is one issue that is a ground effect. For this drone is jointly developed with the Beijing Technology University. They are in charge of the ground part, and we are responsible for the flight. On our test bench, and we did some tests for this aircraft. About the testing of simulation method, in the pure simulation process, we found that the nearer to the ground, the flow can be more prone to disturbances or instability. There can be some fluctuation in terms of the proportion from the ground. The thrust fluctuation is a breakdown of the thrust, including for the blade and for the thrust, and for the duct, and also for the blade. In the ground effect area, the changes in thrust may result in 37% of the total thrust fluctuation. In 1 or 2 distributed duct fans, there can be dynamic differences in terms of thrust. As a result, the pitch will be large. So we need to have more in-depth modeling in resolving this issue. So for the thrust fluctuation, can we make a prediction when that happens, which will be of great helpfulness until our future modeling. About the progress of testing and modeling, we hope that we can introduce the smallest sensing system in the air car to get the best modeling, because we know for the thrust and to have the wind research and dynamic pressure fluctuation, the sensing cost is very high. The dynamic pressure sensor may cost more than 10,000 RMB. If we deploy multiple sensors, the total cost will be high. So we hope that by the motor voltage and the current, by the height and the rotating sensors, we can realize ducted fan thrust on ground effect modeling. because the ground effect may have the impact on the disturbances. It mainly reflected on the power and the rotation. So based on this method and also some of the classic aerodynamic concepts, we have the ground effect modeling for the thrust. In terms of the average force, we use the IG model. There is an exponential modification on that. For each propeller by the experiment, we can get the prediction about average thrust. And meta-learning is used in modeling different IGE heights are labeled as different tasks to enhance generalization. That is the purpose of the meta-learning. So for the ground effect total thrust that can be predicted, we can transfer it into the physical formula deducted average model plus FA, the transient force. It is trained by the neural network. We use the machine learning method, the meta-learning method. We mainly control the revolution, current, voltage, and the height. In the neural network training, we introduce in some the laws, functions that are related or non-related with height. That is a loss function. It looks difficult, but actually it's okay. Calculation volume is not so large. That is a process of training. We use different revolution and height results, and for training, we use consumption level computer, the PC, and 12 minutes of training, we can get one good result. We also verified the dimensionality reduction algorithm in the process of modeling and independence of the parameters for the relevant factors in terms of iteration times, and we made some verification. We just found that they can be independent with different heights. For the transient force calculation, we can lay a reliable mathematical basis. In the test bench verification, that is a final step. In the structure of data set, by the 6 cases and 3 revolution, and for the verification, we have the 4 times radius and also the 0.8 radius model testing. The result for verification, the gray area, is the experiment line. For the orange line is for prediction. We may see that in the model that is basically close unto the line, and there is a delay in time. So in the future, we may need to resolve the issue about the time delay. We also need to emphasize that in the whole process of prediction, it only took about 5 seconds. That is quite fast. If we could squeeze the time to more within 1 second or 0.5 second, we can get the online or the real-time prediction. The precision for the prediction that is in line with engineering requirement with low fluctuation. To sum up, in the flight control process, in particular for the aero car facing with the complicated meteorological condition in the urban areas, we can not only rely on traditional modeling and control method, we can borrow from some AI algorithms so that we can ensure the large-scale and high-density flight can be safer and smoother in cities. Thank you.
Thank you very much. And please stay on the stage because we will have make my translator. Stay on the stage, and please, all speakers from the session come back up onto the stage. And sorry. We will have a discussion on this, and you could see already with what we had here that it's, you know, the subjects are overlapping because sure, you could need the AI also in the propulsion system. Also may need, and also I would like this you of Volon, if you could come up to the stage as well, because just one, yeah, like this, I think. Yeah. Okay, so we are fine. We are here, and if anybody of you has a question to any one of the speakers, everybody has a microphone, I think, yes. And you have your translators ready so that you will understand the questions. So if anybody has a question, lift your hand and, or no, come up to the right-hand corner of the panel, because there we will ask for questions. I have a question at the beginning for Mr. Mundekla from Christian from Red Aircraft. You showed this big 12-cylinder motor, which may be a solution for the large commuter aircraft. You also showed that you have different smaller aircraft. Will there be also available systems with a generator with a smaller aircraft, so that we would have a smaller propulsion or energy generating unit for smaller eVTOL? Because I think the 12-cylinder at the top range of energy would need it, but probably people would be looking into the smaller first. And what would be the smaller version which will come first?
Okay. As already mentioned during my presentation, we have foreseen also smaller engine models beside the V12, which is currently in production. So V836 and I4, meaning 400, 300, and 200 horsepower. And most likely the 200 horsepower will come first, as the demand is bigger there. So this means electrically 140 kilowatt, down to 140 kilowatt.
Okay. I have a question on Volon, because yesterday we heard, I think, Aerofugia is using your motors. And so are there any other company which is using the propulsion system, and this is a special thing, also with hybrid solutions? So are you also supplying hybrid solution with turbines or with combustion engines?
谢谢魏丽的这个提问啊。那的确，昨天就像郭总说。
Thank you very much. So, like Mr. Guo from Aerofugia mentioned, so we have already registered a joint venture on September 19, and so far we mainly focus on eVTOL and the propulsion system, about 70 to 100 kilowatt hours. So we will first of all focus on the TC, from the design to verification to development and etc. Other than Aerofugia, we also have other clients like the commercial aircraft and others, but due to the non-disclosure agreements we signed, we couldn't mention their names. We have some government-backed clients and some commercial guests. Bolong is also a a global company other than domestic partners. We also have international partners. So we are expanding overseas. So that's for pure eVTOL, pure electric eVTOL. And for hybrid, I talked about extended range, and I see in my presentation we are working on the engine side, and we also would go down the path of commercialization together with the TC.
Okay. Sorry. I thought as you were not coming up the stairs, I thought we have enough. But I have a spare microphone for you. Have a question for Montavista on the battery side. You're promising really nice high values. You also mentioned that there is a time frame for the values, but let's say ready-to-use cell, let's say I'm an eVTOL manufacturer. I want to get into test flying this year. What would be the cells you could deliver that I can use in my power pack? And are you also looking into the certification side of the cells? Because this will be the key question in aviation.
Okay, thank you, Willi. Actually, that's a good question. Currently, for eVTOL high power series, our energy density we can provide currently is 400 watt-hour per kilogram. So that's not as high as our high energy density series, but it's certainly is higher than normal lithium-ion battery. And we expect maybe next year we will raise, now in our lab, we are validating 450. 500 certainly is something we think in next year we also try to push the high power series to 500. At the same time, actually the standard is something we desperately need, because a lot of manufacturers in China and also abroad, we found different companies that have different requirements, especially format, the size of our cells. So if for our startup company, we have much more customers we can handle, much more. That problem is each requirement, the demand, actually the quantity is small. So we cannot make money, actually we're burning money. But if we have a standard, say majority of manufacturers will adopt one type, what kind of a similar size, right? So we have a handle, say we put all our resources to develop this type of cells. That will make the validation much easier, right?
Okay, the second part of my question was like, you also looking into aeronautical certification with your cells already, like on the thing is the standards are still in development, yeah. But especially with the cells you're promising, I could think especially the aircraft we talked about yesterday, like Mosaic type of aircraft, which are smaller aircraft, that this may be companies who say, okay, we need to sell fast. We don't need a full certification. Maybe we need an ASTM compliance, which may be lower than an EASA or CAAC certified cell. So do you have some contact there already to this kind of clients? And which certification you're looking at the moment at when you work on your cells?
Actually, we are trying to push, say, in the future, we can certify a power unit. Say all this small scale electrical aircraft can adopt a kind of standard power system. It's a pack. It's like a EV's pack, kind of standardized pack. Well, certainly it's not only one, because different aircraft may have different demand of energy capacity. So, well, if we can limit it to 3, 4, actually, I think that's very helpful.
Okay, I have the next question. Any question? Yeah, I just sent.
I have a question.
Yeah, Joshua.
Thanks. I had a question about the ducted fan ground effect, and if you've seen a certain disk loading where ground effect is beneficial for ducted fans, low enough disk loading where it's actually helping, for like the really smaller, lighter, single-person sort of stuff.
So your question is mentioned about the duct fan effect, ground effect on the duct fan for the small scale.
Yeah, like low disk loading, like personal aircraft.
Personal aircraft. Yes, for the duct fan applications, because of the, I think it's you can use the momentum theory. You can derive that at the same diameters and also the same thrust, because of duct fan can control the exhaust areas of the exhaust flow, so we can achieve a higher thrust compared to the same condition as propellers. So that's the main advantage of the duct fan, but also the disadvantage is duct itself. It will bring the additional weight for the flying cars or the eVTOLs. So that's questions we must, or the issues we must concentrate to solve it. And so the carbon fibers will be an option. And also much more important, I think, for the integration design, we must concerning about the duct itself integrated with batteries, so we can save the structural part of the weight of the battery, make the common parts as the duct fan duct and also the battery structures. So that's my answer.
Okay.
Thanks. We'll follow up after.
I have a question on your presentation, Mr. Weiwei, which you had on the hybrid propulsion system. You mentioned also Chinese turbines, which could be, or domestic turbines, which could be used. Are there any domestic certified small turbines, like in the PT6 class, or smaller, let's say 200 kilograms, which are certified already? Because this is one challenge I heard a lot of people have when they want to do a system based on a turbine. There is only a very small selection of turbines which would be available, which can or are certified after Part 23 or the equivalent for the propulsion systems.
谢谢。现在确实是这样，就是核心机我们选。
Indeed, we don't have that many options. You mentioned PT6. In terms of structure, it's quite long. It has different axles and different two shafts, separated design. So that's early configuration is not that ideal. And now we may use more coaxial turbine system, because our focus is the power generation system that's below 1,000 horsepower. Right now, we don't have that many selections. That's true. We are willing to work with our European partners to develop more options. But given the geopolitical issues, we may also need to consider domestic suppliers.
Okay. So there is, I think we are right, and we can follow up this later. As my understanding, there is no small 35 turbine which was fit there, so we have to develop it. I have a question to Julian, and I think, yeah, we nearly running out of time. The fuel cell system you developed for this aircraft up to flying with the electric system and with the fuel system now in very fast time, as I see other projects taking much, much longer. Okay, you working on a based on an existing aircraft and it's just a propulsion system, but and still, is there any follow-up planned of this? So when you once finish the research work, will it then come to the garage and will be used for nothing? Or are you imagining that maybe working with a manufacturer, maybe working with somebody and finalizing this propulsion system, especially the one with the hybrid, but also the electric one, so that somebody could use it? Because I think there is a use or the need for such propulsion systems ready to fly.
Yeah, so after the first flight, we're still planning on flying it further and further. So it's not just the first flight. The end goal is to fly over the Swiss Alps. So this is just a project goal. And afterwards, we want to keep it flying, keep it in the air, test more and get more flight hours. And we do not have a specific goal of later on selling it as a plane. So we would be open to it, but as we are a student project, it would be more of a company which approaches us and says, well, we want to do it, can you help us out, and not the other way around. But definitely an option we would be open to.
Maybe you have to find some money and start a startup.
Yeah, we could do, but we would need a lot of money.
Yeah, okay. I think, yes. Any question here?
下面还有问题吗？ Question?
Not for the moment.
Excuse me.
Yes, you do have a question. Yeah.
如果有机会的话，还是请教一下。
I have one question, and for battery, because I used to work in Xinwanda for power battery for more than 10 years. So I'm curious. I want that a battery can be applied in e-flight, but a high power battery is not only about the performance, but also safety and also cycling. It's not only the safety of the cell, but the safety of the whole system. So in this part, I think we still have a long way to go. So you just mentioned about for the battery speaker, you mentioned about standardization. So in e-flight for ADVANCE is for the 4680 for car. Do we have the liquid or semi-solid as the 46135 standardized model for aircraft? Is it possible? Can I answer in Chinese? So for the battery standardization, for the lithium metal battery, we usually have the method of the piling or stacking. The stacking is usually based on pouch cell. The advantage of pouch cell is that different manufacturers on dimensions, on the spatial requirement can be flexible. Therefore, the cell is like more nimble. But there is some safety design requirement, for instance, cylindrical cell. It is not so can be more difficult in the designing process for pouch cells. And now some manufacturers, they have the pack with the heating, with the cooling, and also the vent. Different types of design, that is in the systemic part, and we can do them all. For instance, now we're joining with the clients on several power systems. We have the subsystem and the mega system. In the master system, the energy density can be like 400 watt per kilogram. The cycling can be poor, a little bit poor. For the high density, the cycling can be some 200 or 500 watt per kilogram, 200 cycles. When talking about eVTOL cell, what we can do now is if there are some needs from the aircraft, they are willing to accept the new products, emerging technology. we are willing to provide the 400 watt per kilogram with some 500 cycles. The kind of sale that we can do. For many manufacturers right now, they may worry about our supply ability, namely the mass production, and also worry about the price. Indeed, the price compared with lithium-ion battery can be higher, more expensive, but there is about the issue of the egg and the chicken, which comes first. You need to have the production volume first, then we can drop the cost. It's the economy of scale. With the volume in place, the cost will be similar to lithium-ion battery. Only with high demand, we can lower the price. I hope I can answer your question.
Okay, thank you very much. And we have to stop here for the next session already. Thank you, my panelists. And I'm sure we will continue talking afterwards at the lunch break and stuff like this. So thank you very much. And the next session, I hand over to Gao.
Now we concluded the subject 4, and indeed a lot of topics and for discussion. Subject 5 is about supply chain and infrastructure. The first speaker is from CAAC, the Operation Monitoring Center of CAAC, former Deputy Director, Professor-level Senior Engineer, Mr. Tian Zhencai. In Hunan Air Show, I just met Mr. Tian. The topic is low-altitude intelligent transportation system, the core of low-altitude economy. Because we have tight schedule, we don't have the time for tea break, but we have the snacks outside. You may fetch the food anytime. Thank you, Mr. Wang, dear guests. My first time in e-flight forum. Thank you for invitation. Before going into the topic, introducing about myself. I graduated from Zhejiang University, then in EU, France. In my whole professional career, I was in civil aviation about the flight system, namely the air system mentioned by the CAC, and we mainly focus on the air control, the communication facility, about the planning, infrastructure, and also about the opening of the flight routes. That is about my professional career. I retired last year. Therefore, today's discussion is based on my personal idea. Thank you. Three agendas. To start with, one slide about LAE and underlying logic. In the past few years, the whole society's understanding about LAE cannot be underestimated. Everybody believes that for the below 6,000 meters and the airspace is waiting to be developed. In China and in EU, we are kind of different in methods, and we still need to develop more the low-altitude space. It requires participation for the whole society with the guidance of the government. It is a systemic work. It requires all kinds of ministries and departments in China and the distribution of labor among the central and the local governments. We need to lay a solid foundation. It requires the joint effort of the whole society to make us fly further, to fly safer. So we have the central government affairs, ministry level, and also the local government level, mainly for execution. So for the three levels are indispensable. We need to coordinate and promote together. We also need to clarify. For LAE in China, there are three features. To start with, the strategy, strategic significance, and meaning. We heard a lot in the past 2 days. will not elaborate. The second part is about integration of technology, industry, academy, research, and exchanges at home and abroad, and also standardization. For time's sake, I may not be able to elaborate all different aspects. When talking about the strategy for airspace resources lower than 6,000 meters in Chinese mainland, is limited but still pending for development by joint participation, including the governments, B side and C side. In promoting the industrial transformation and upgrading the scientific computation, it plays an important role. Personally, I think it is about the Internet of Things mega application scenario. In terms of integration or fusion, we talked about many micro perspectives. I want to share something about intermediate level. It means that we need to integrate LAE into the national strategy overall plans in terms of scientific innovation, industrial upgrading, the management system deepening, in-depth reform, regional coordination development, and other 12 important strategies and deployment in China's national government. We need to sync with the national plan and strategy. Thirdly, standardization in terms of top design and national laws and regulations. We need to deepen the airspace reform. It is the urgent task. Everybody is doing their part. We need to build the precondition suitable for new technology application, new model, and the market rules. That is a concern for all of us, and we need to practice by example. As for the new quality productive forces and the new type of production relationship, now in China we have some guiding policies, in industrial policies and safety policies, and also the policies from the local governments, as well as for professionals, and the laws and regulation standard formulation. They are important assets for the new quality productive forces. We can summarize the features for the new development phase. There are different types of applications based on the pilot tests in localities. Manufacturing is a hot topic. Many entrepreneurs and many veterans, I think all of you may have better understanding than me. Now we have made excellent aircraft, but how to operate it, put it into sky? For the transport and cargo aircraft, the transportation market is based on thousands of aircrafts. For industrial level, represented by drones, it is based on the magnitude of 100,000. That is about the scale of economy, that is the future and our hope. Everybody is working hard for the scenario, for the best scenario to happen. So we need to boost operation to let the aircraft fly. Capital is important, but it's mainly in manufacturing side. We also need to export. Currently, all kinds of export methods in China and overseas market. That is, overall, it is a positive for manufacturing. In China, for below 6,000 meters, in particular below 3,000 airspace development, we are in urgent need of commercial infrastructure. Local governments are passionate in LAE, introducing the high-end industries and also the industrial park. Of course, there is some employment creation because of such efforts, but the industry is kind of cooled down. Because we have the commercial flight experience and coordination from different parties, the industry is sober. Everybody is working on the modification of the rules and regulations and formulation of standards. Last night during the exchanges, I heard some complaints from the industrial peers, but I told them that it is the responsibility from the whole society. When we seek consultation opinions for the new laws, we should participate so that we can jointly promote the healthy development of the industry. There are the blossom of different kinds of scenarios, but they are all in the proof of concept stage, in particular industrial drones. Therefore, what is the pathway for new infrastructure, including the airworthy aircraft? We talked about the airworthiness certification yesterday, a hot topic, and the CAA suitable the vertiport. We don't need to have the fancy vertiport, but we should have comprehensive functions including logistics and safety, iterative management service platform, not fancy platform, but strong in functions, data sharing capacity, as well as digital twin, the fusion with reality, the compliance and with reality figures, auxiliary facilities on the flight rules, as well as the more advanced, not out-of-date rules and regulations. It requires joint efforts of all of us contributing our recommendations.
How to make the low-altitude economy take off successfully? Well, our ultimate goal is the intelligent transportation system integrating airspace and ground. The 2D network is already quite mature, both in China and in the EU and the US. From our past experience, we know that once the ground development is mature, we need to move up into the sky. That means we would need the intelligent air traffic control system and the air route network, including takeoff and landing sites, supporting infrastructures. For hybrid, one site and 600-meter runway would be good enough. Also, we would need new policies and regulations, as well as professionals with some new competencies. So that's an entire new system covering aviation manufacturing, transportation, urban governance, emergency rescue, industrial inspections, and agriculture and forestry protections. So we need to adopt a new system engineering methodology and relevant technologies fully. And involve all the academic scholars to convert the research outcomes into practical applications. We need to fully leverage the government's guiding role and the market's leading role to significantly reduce the costs of low-altitude operations. Earlier on, we had questions about cost of batteries, and Professor Zhang also responded to this question. So, wide market acceptance and active participation are the key for us to effectively promote low-altitude economy.
陆空融合的综合的一个交通管理体系啊，所以呢，我们国家的发展思路是先隔离后融合。
So the development philosophy is separate first and integrate later. Airspace separation is crucial. Cargo first and passenger later. Also, this is the combination of the air control system. We could carry out pilot programs to refine the route management. And once we reach 100,000, we will need to update our management systems. Also, we need to improve the system reliability. Starting from Part 23, we would gradually move towards Part 25 standards. Also, we need to verify and validate the segregated, interrogated, and integrated airspace operation rule. This is a picture we generate from AI, and as you can see, all of these are in the same platform, and they fully share the information. And all of these employ the latest generation of IT technologies. So we need to. Those eVTOLs need to become commercial, off-the-shelf product based on experimental validation. So we need to build a smart city management platform. It's developed at a later stage, so it has lots of new technologies embedded in it, including spatial temporal, big data, 3D geo information, IoT, big data, and etc. IoT in particular is important for the development of this platform. About a flight route network, including commercial routes, specialized scenario routes, and cargo transport routes, we need to treat them differently. Commercial routes are mainly for passenger transport, and this needs to be managed in a top strict manner. And for specialized scenario routes, for instance, forest fire prevention, agricultural inspection, and etc., the safety standards can be determined based on specific requirements. And commercial UAVs and industrial UAVs are involved in this specialized scenarios. So for cargo transport, we see UAVs replacing people taking cargoes from the root of the mountain to the top. So moving on, I'll talk about the present and future of infrastructure development. So we need to focus on these issues. Well, the main body involved in development should be clarified. And the focus of this should be the reconstruction of airspace boundaries. Operating entities such as organizational structures and operational mechanisms. We see that integrated manufacturing and logistics platform companies are also joining the force. So these are the successful cases. Well, in the interest of time, I won't go on the details. I will leave my presentation here so you can have a look if you're interested. You are all entrepreneurs, so here are just some tips and some takeaways. So we need to make breakthroughs in those technological bottleneck areas. Also, we should be involved in rule setting and standard setting, so as to be proactive and be part of that supply chain eventually. So the wind is strong enough, even pigs can fly, and when we on the racetrack, the whites can reach the finish line. The ultimate path of low-altitude economy isn't the sky, but within the boundaries of our understanding and expansiveness of our thinking. We need to figure out and clarify the policies, grasp the big picture, leverage our strengths, and keep pace to truly soar with the wings of sustainability.
It's very interesting, especially what you were talking now, because we will later have the AI session where we'll talk about exactly the same thing, and we think this is one of the crucial things in getting an economy of scale done. And now we jump again from the very big picture to the small aircraft, to the Light Sport Aircraft Association, because when I was planning this event, we thought it would be very useful if, in addition to what Scott told us yesterday, to the approach which they have on Mosaic, just to learn a little bit more on the Llama organization itself. But I think with so many, with so many manufacturers, companies ramping up for the low altitude economy, it would be nice to have maybe also some connections to the Mosaic and Llama approach for getting the aircraft into the operations sooner. So for this, I'm happy to have Margaret Severin here. She's giving us an update of what Llama is doing. Margaret, stage is yours. Yeah, microphones are enough here. Thanks. Yes.
Yeah. Thank you. Yeah, got it. Well, thank you for your generous welcome, and thank you for attending the 9th Annual e-Flight Forum. With the recent release of Mosaic in the United States, the timing is perfect for Llama to be at this forum. Today, I'd like to offer an overview of Llama as it has evolved to an international association. Thank you to all for your participating in this global event. Okay. Llama is a not-for-profit trade association that advocates for manufacturers and suppliers to the light aircraft industry. Our work shapes policy and influences standards. This result is an improved industry environment as Llama informs and provides guidance to members. To Llama, light aircraft includes all categories, classes, and types of flying craft up to 4-seat capacity, microlight, ultralight, and including emerging technologies such as powered lift and eVTOLs. China is expanding these new technologies that are integrating into the new era of aviation. What makes Llama different from every other association? Today, Llama has a very distinct position in the industry. Here is the key point about Llama, and this is defining. Llama members provide aircraft and components that meet Civil Aviation Authority safety requirements worldwide through self-declarative means of compliance. This means aircraft that do not require a type certificate. Light sport aircraft are self-declarative. The manufacturer declares the design and production conforms to the ASTM standards. How did this come to be? Let's look at a little background of Llama. Larry Burke co-founded the Light Aircraft Manufacturers Association in 1984 to support ultralight manufacturers and their customers. Llama was heavily involved in the creation of consensus standards for both ultralight and microlight aircraft, which laid the groundwork for LSA certification. He played a pivotal role in the development of the light sport aircraft, LSA, category, working to establish safety and design standards. These standards were developed working hand in hand with the FAA and ASTM, where industry leaders volunteer to specify and design and operating standards for the LSA industry. Llama was crucial in moving the industry from the often unregulated ultralight era to the more structured LSA framework, which included safety and performance standards. Well, let's see where that led. Just as Llama was instrumental in the development of ultralight and light aircraft airworthiness and quality assurance standards in the 1980s, Llama again is changing the skies. With Mosaic, Llama has been successful beyond original expectations at persuading FAA to open opportunities for manufacturers and companies of light sport and similar aircraft. FAA accepted every Llama request for Mosaic. Llama originally requested SLSA, fully built, not kit, gyroplanes, aerial work and commercial use, electric propulsion, single lever control with in-flight adjustable prop. Llama sits on the executive committee of the ASTM Industry Consensus Standards. I'd like to introduce the Llama Board of Directors. The Llama Board is made up of industry leaders from the United States and Europe that are well connected with the respective governments, Civil Aviation Authority, and industry associations. Marino Boric, aviation journalist of Germany. I'm sure you've read many of his articles in Flying Pages. Tom Gunnarsson, lead of regulatory affairs at Wisk, a wholly owned subsidiary of Boeing that is developing an autonomous four-seat air taxi. Phil Solomon, CFO, Heart of Virginia Aviation, one of the larger light sport flight schools in the U.S. Phil Lockwood, CEO and owner of Lockwood Aviation Group and creator of the fabulous twin-engine AirCam. Mark Becker, manager of aircraft business at BRP Rotax, by far the largest engine provider in the light sport arena. And Scott Severin, our president and chairman of the board, the owner of U.S. Sport Planes, one of the more successful light sport service centers in the U.S. These leaders have been working to evolve aviation. The big opportunity and trend in the regulatory environment is moving from type certified aircraft to self-declarative compliance. Remember, self-declarative is where Llama specializes. Type certification is cumbersome, takes a long time, which freezes advancement, and is expensive. Self-declarative compliance is comparatively nimble, more cost-effective, and adapts to new emerging technologies. Who is Llama for? Those visionaries and businesses that want firsthand knowledge of regulatory and market environments in the U.S. and around the globe. These leaders influence Llama initiatives. Llama improves markets. We are at a time where Llama members are positively shaping the regulation for their industry. This QR code will take you to llama.biz, our website. Llama works together with associations and governments that affect change. Llama has decades of developing excellent relationships to make things happen. And feel free to visit our website, llama.biz. And this is our, that's our landing page. Although January 1, we are releasing a new website. So be sure and come back and check it out. All right, thank you all for your attention. I'm honored to present for you today. I know there are complex issues, and Llama is here to help navigate the path. Together we can do it.
Thank you, Madam Margaret Severin, for your speech. In the process of the GA in the U.S. development, Llama played an important role, as mentioned by Scott. The sports aviation accounts for a large percentage. The management of such aircraft, there is one good practice rely on the association or EAA or Llama. In China, for CAAC, there is also the classification of LSA. But for the management in the industry, we can borrow from the experience from the U.S., delegate the associations of industry of larger role. If all the responsibilities fall on CAA, it's very hard for it to spread itself too thin. For the U.S. and for Czechoslovakia and for these countries, and they have similar experience in representing the CAA to manage the small to medium type aircraft. Associations play an important role. We can do the same thing, but how to implement it requires more thinking, more institutional arrangement so that we can better manage the industry. Thank you. So our next speaker is the iWear SVP, Xu Weiyue. The topic is building a safe and efficient low-altitude intelligent network using Beidou grid codes. I'm grateful for the invitation. It is my honor to share with you about the Beidou grid code to construct the safe and efficient, the low-altitude intelligent network. As mentioned by Mr. Tian from CAC, and we're just one genre or one school, and in the industry niche, we use the Beidou grid code to construct the management system. The two parts of my speech, the first one, introduction about the Beidou code. The second is about application and practices in the projects. The inventor of the Beidou grid code is Mr. Chen Zhenxi from Peking University. Based on this system and its application at different levels, it got the National Scientific Advancement Award and the National Defense Scientific Award for Beidou code. Initially, we mainly focus on national defense. The theory is that for the expression of the globe based on the longitude and altitude plus height, so that we have the positioning of different places in the world. But for the Beidou code, we have a series of the figures and values based on 2 the power of x. So we have the extended coding for the longitude and the altitude. So from the core of the Earth to the surface of the Earth and the outer surface, some 500,000 kilograms into different grid to have the regional expression method. So in the national standard, there are 32 layers. The lowest layer is 1.5 centimeter in terms of the grid. Based on different objects in different scenarios, application, we may have 1.5 centimeters or the meter level grid or 16 meter level. In the urban low altitude, we mainly adopt 1 meter grid. In urban areas, we may use 8 meter grid. So the grid is based on the current spatial arrangement in the globe and objects arrangements to have the fast real-time expression. We use the lowest grid data volume to express a moving or static object. One major advantage is that the calculation involved is very small. Secondly, it has high confidentiality. There is no precise description of the object. What's more, in terms of time, the theory just dissects the time. 60,000 BC and 60,000 AC and different time frame in the world, they use the different value to express. The core is that we have the fast delta, the value delta calculation. Because for humans, we need to know clearly about the expression, but in terms of the progressing of time, for computer is more like irregular. We have the different kinds of methods. For instance, we have the traditional decimal and the more different methods to express the time, but now we abandon all these traditional methods. We use a new method to express the time. And for the geosort theory, for the spatial and the temporal coding, we have the continuous expression about the change in the world. So for some of the 4-dimensional calculation in the space, and we just downgraded to the 2-dimensional calculation, so we can transfer a moving, dynamic topic to the static dissection comparison. In the past, we need to have the sector-based, a vector-based calculation. Now it's based on GPU, including the prediction for the collision in the air and also the alert about the flight route conflict, and we can give some pre-warning. The technology already participated in the 3 9 national standards, 3 international standards, and several industrial standards. It's widely applied in all kinds of industries. In low altitude, the core issue we can solve to start with is the fast modeling for the aerospace, because for low altitude modeling, it's not simply about the 3-dimensional mapping. We also need to resolve the location issue in the space, the environmental factors, as well as the social factors and nature. So in one certain region to give effective expression, that is about all kinds of elements in flight. In many projects, the leaders just told me that we output the 2.5-dimensional map to you, then you can fly, right? I told him it's not that simple, because I need to have the comprehensive, the location and the flight nature expression. So the grid plays 2 roles. The first one is the coding in the grid. It is the absolute physical space domain. It means that at which height we're flying. Second is about in the location, the ground status, the spatial occupation, the electromagnetic, environmental, social environment. It is more like an index for all these features. So by these two features, we can quickly calculate in the overall flight space which areas are available for flight and which are not, in which areas can be available in the future and which are not. So based on that, we have the full spatial integrated network modeling based on flight, compared with traditional the geological information-based modeling. That is a different concept. So we have the mega database technology. We use the grid as a component, all kinds of data. We get the pre-calculation. We also participate in the overall flight dynamic calculation. Now the updating frequency is 1 second. In coordination, we have the supercomputing technology. We have already verified the system. In the static status, the index compared with real-time system, we can improve the efficiency by 10 times. In calculation based on longitude and altitude, the vector calculation, in comparison, the basic calculation can be like 10 to 60 times. In the higher complicated calculation, some indicators can get the 3 magnitude improvement in performance. About the engineering practices in the project, the Beidou Fuxi was founded in 2022. In the past, we focused on national defense. In 2022, China opened up the low altitude. With the support of the Peking University, we established the Beidou Fuxi in Information Technology Civil Company Limited.
So far in low altitude, we have quite a wide application of this grid system. Well, in the past, the management target is the single individual, but now we could allow temporal and spatial management, covering all the elements. So that means a different magnitude of managing targets. We could manage about 100,000 aircrafts within an urban area. We could also label the entire aerospace with seamless integration, and also submentioned that we need to fly aircrafts to the docks and to the residential buildings. So we need to make sure that the spatial and time precision is 1 centimeter and 1 millisecond. Is there any sound of this video? I'll just carry on then. So this is about flight route planning. Now we can now do smart route planning. This route is auto-generated. You don't need to do manned inspection. Before that, you just need to choose the starting point and end point, and we could just exchange data with the data control system and then plan the route. Also, this would consider the weight of the aircraft, the size of the aircraft, the airflow, and etc. when designing the route. This is from an outdoor to an indoor path, and the entire modeling system allows seamless integration, covering different sizes of aircraft and targets and buildings. Could you turn up the volume a bit? The second part is the traffic light support project. This is a real case. It's quite a straightforward application. weather information and transport information are all embedded into the system. And we could also support different flying protocols. So 2 aircrafts are about to crash, and this risk is identified by the system. The more powerful aircraft is then directed to move upward. They could also be directed to move to the left or to the right side. This is just an example. Emergency aircraft has a greater right of way, so non-emergency aircraft, they need to go the other way to avoid crashing. This is an important function for emergency and rescue. That's just an example of only part of the functionalities that we are able to do, and this is just part of the examples that we carried out since 2022. We carried out lots of projects, including in Hefei, Chengdu, and Changchun. You can see there are lots of engineering applications. Our systems are also in constant iteration. This is the coverage of our Tianjin-Beicheng project by CCTV. It's broadcasted as a typical example, showcasing the achievements made for high-quality development. And here I'd like to invite all of you to come to Beicheng for inspection and for guidance. Other than system development, we have also been widely involved in the value integration across the upper and downstream of the supply chain. So here I'd like to take the opportunity to invite all of you to join forces with Beidou Fuxi. This is my QR code, and Wang Yin is from the fund management company. If you have any investment or financing needs, then please feel free to contact us.
Yes, our next speaker, it's a quite different subject, but still all is the infrastructure which we have to build up for an system like eVTOLs, electric aircraft, or short called the low altitude economy, charging. And we have a specialist here on charging coming from Australia. So you see, we really get around the world with our speakers. So Josh, please come up to the stage and tell us the latest information on your charging systems and where you are with getting the infrastructure up. Micro. Thank you. Thank you.
Great. Thank you for having me. Ni hao. So as mentioned, Joshua Portlock from Electro Aero in Australia, but we actually export most of our products. So there is a growing activity of electric flight in Australia because we've been the first to operate 2-seat training aircraft, which I'll touch on more. But the eVTOL industry has been led by the Chinese and the US and some Europe activities. So most of our activity has been export. So I'll just click through here. So I wanted to emphasize that there are a lot of challenges trying to implement car charging standards in aviation. So we should really avoid that, avoid the mistakes made in automotive charging, and actually focus on aviation-centric charging infrastructure. I won't get in the weeds of the exact issues, but you can imagine the quality standards are not the same. We've already seen that in the airframers aren't able to use automotive parts, and it's even similar for charging as well. And there's really several major differences. The fact that cars have one inlet, most aircraft are opting for 2 or more inlets for redundancy across the airframe and to reduce the amount of copper weight on board the aircraft to charge these distributed batteries, especially if they're wing-based batteries. cars park close because they don't have 50-foot wingspans, so they can park quite close to the chargers and have short cables. With these 50-foot wingspan eVTOLs, you need to bring the charger, at least the cable, but preferably the charger up to the aircraft. If you have to drag 50 feet of cable along the ground, especially these bitumen tarmac phaetos, you're going to have a lot of wear and tear issues. And that has already been proven to be a case in automotive charging when cars park with their inlets far away from the charging station. If they're being dragged along the ground regularly, especially the liquid-cooled cables, you're going to get wear and tear and have issues with maintenance. So then the other aspect is that automotive DC fast charging is opportunistic, meaning that you're driving along the freeway, you're getting low on battery, where's the nearest charger? And you'll find because of that, they're underutilized and not as critical, because if one's not working, you just go to the next one. And in an eVTOL environment, you have these very dense areas of takeoff and landing where you have to have critical charging infrastructure working all the time. So you can't be just opportunistically flying to the next site or landing at one site and going, oh, this charger doesn't work, where do I go now? It's not the same sort of situation where you can just drive to the next charger. And the last point I'll make is that cars are not as weight sensitive as we've seen with the battery talks and hybridization. So to get the most out of these battery electric flights, we want to have the least weight on board. So we don't want to necessarily have a really heavy off-board liquid cooling solution. We really want to focus on onboard, so we want to focus on off-board cooling the batteries. So a lot of the eVTOLs, especially in North America, are off-boarding their liquid cooling, and we're helping with that to provide the electricity and the cooling systems while charging. So last points on problematic car chargers. They're tall and stationary usually, so that's guaranteed wing rash if you're trying to maneuver this big fixed-wing or VTOL aircraft near it. Cables wearing out. Cable lengths are also limited in the conventional car charging standards like CCS 1 and 2 because of the way the communications works. And then they don't support more advanced software algorithms that we're trying to work on as well. So we want to make them modular and upgradable for the future, and the automotive standards aren't going to do that for us. So we've actually been charging electric aircraft since 2016. I founded the company in 2014 when we started working on various eVTOL projects, a lot of confidential projects around the world. And now we've been really just being the leader of aviation charging standards around the world and helping everyone conform to one standard, or at least a few standards. So we operated the world's first commercial electric aircraft back in 2017, and we've been operating that through our sister company, Fly-On-E, ever since. We've got 3 two-seat electric aircraft that we're operating commercially with over 1,000 commercial flight hours profitably. So that's quite unique in this industry. And both Electra Aero and Fly-On-E are proudly profitably bootstrapping compared to a lot of money being sunk into this industry. So we have a lot of products that we focus on the end-to-end solutions for aviation charging, not just the portability of the charger, that's critical, like our 80 kilowatt you see there, but also containerized batteries, because a lot of airports don't have enough power, especially when you look at eVTOL, to fast charge these aircraft to turn them around again. So we're often adding battery containerized solutions to supplement the grid. And then onboard the aircraft, we're also providing the charge control units in the smallest aviation certified form factor, about the size of a credit card, which is substantially smaller than automotive charge control units and specialized for aviation. So we've got a unique position there to support the aviation industry. And this is actually the charger inlet for GBT. So I'll talk about the GBT charging standard and our charging standard with SAE International, which uses the same form factor. So that's very important for the Chinese customers to adopt that to help roll that out internationally. Now here's 4 of our existing airframe customers, and you can see the varying range of performance and flight envelopes. You can imagine, we've talked about it extensively through the show, but all of them can benefit from universally standardizing to one inlet, so the same charging infrastructure is on all of the charging stations. So we've got a great bunch of partners, from Arovi doing software management solutions at energy at airports, cable management solutions with LPA, Altiport software planning, and Vertisim. So Vertisim are the world leaders at simulating airport operations in the US and around the world, and they've been doing some great work where they've really been proving the need for this portable charging infrastructure for us, and we're promoting their activities as well. So it's really about having this critical mobile charging solutions. Because if you show up at an airport and start trying to operate commercially, if you don't have the charging infrastructure, it's not going to be economically viable. If you can only slow trickle charge from a standard wall outlet, and you can only do like 1 flight a day, that might be fine for prototype flight testing, but just completely not viable for commercial operations. And airports are notoriously bad at upgrading their infrastructure, very slow gestation cycles, often government run or government funded, either way, slow and bureaucratic. So you want to have solutions that can be dropped in, literally trucked in, dropped down, and start charging from day one. And then what energy source you charge that containerized battery from could be the grid, whatever limited grid power you have, but ideally a solar solution, ideally rooftop is the most affordable, but you've got large roofs at both terminals and hangars, so that's the best first option. But airports often have large no-fly zones, no clearing areas that can be for solar as well. So let's talk standards. So I mentioned that the SAE International Standard I founded 7 years ago now actually recommended the GBT standard. So this is the Chinese DC fast charging standard. It's substantially more compact than CCS 1 and 2, the US and European standard. And we've been adopting that over the last 7 years and trying to encourage these European and American companies to adopt it. We've had really good adoption. About 70% of airframers are using GBT, but there's still that 10, 20, 30% using either proprietary standards like Joby's GX coupler at the bottom there that combines liquid cooling and 2 DC connectors, or the megawatt standard because some of the larger 9 to 19-seat aircraft are needing that much power, or unfortunately being lazy and using car charging standards like CCS 1 and 2. So I'll touch on that next. Why not use CCS 1 and 2? So I know I'm preaching to the converted here. All the Chinese manufacturers are using GBT already, but the North Americans tend to default to CCS 1 despite it being an already redundant standard. So even though a lot of the manufacturers have started using CCS 1, the car standard is already moving to Tesla NACS. That's a more compact all-in-one DC-AC coupler. But Tesla's also, the NACS is also not suitable for aviation, which I won't have time to get into. But in aviation, you can't justify this onboard weight of AC to DC converting. So that's what the top half of that coupler is for, is those AC pins. In China, you have a separate DC charger and a separate AC coupler. And without needing the AC coupler or onboard charge converter, you save a lot of weight. So that's why we standardized to GBT early on. It's the most compact, power-dense DC fast charging standard. It uses CAN bus instead of a single wire power line communication, and it is also have an auxiliary power to be able to charge the low voltage 28 volt system in parallel with a high voltage up to 1000 volt system. So there's lots of reasons to implement GBT as a physical coupler, and then even more reasons to adopt SAE's international standard version of it at a software level too. So I won't read you this eye chart entirely, but you can see there's lots of benefits of the Aviation Recommended Practice 6968 that we've been working on for the last 7 years. It is physically backwards compatible with GBT's 234.3 standard for DC fast charging in China, but higher voltages, more automatic, faster starting, a whole bunch of lock improvements, the time it takes to connect, lock, and disconnect, can charge the auxiliary system even while the primary power is off, and it can charge communicate a higher quantity of battery cells. Because as you know, a lot of eVTOLs are running redundant batteries, so you're not just going to have one string of up to 256 cells, you're going to have hundreds of cells in parallel, and you want to communicate all that data back through the charger. So again, a quick overview of what we offer as a service and a product. We offer our miniaturized charge control units. So as much as we're pro GBT and SAE's 6968 standard, we are still supporting CCS 1 and 2 with the same form factor, so they can start with using local chargers and then move to the 6968 standard in the future. We're ISO 9001 quality control certified and 14001 environmental certified, and we've worked with the DO 178 standards, 254 standards, and 160 standards. So from our knowledge, we're the only aviation approved charge control unit, where a lot of the prototypers are still using car charging standard units. And the car charging control units are substantially chunkier because they're not weight optimized. They're not designed to any of these aviation standards, so they'll only really be able to be used in a prototype, and then you'll have to move to something like what we're offering. So we've done a lot of 30, 40, and 80 kilowatt chargers to date. 80 kilowatts our most popular because I say that's doorway transportable, so you can take it through any doorway into a hangar, charge fixed-wing aircraft fairly fast, and eVTOL aircraft a little slower. But we've even used up to 6 of our 80 kilowatt chargers to charge aircraft like the Arch of Midnight at 480 kilowatts. So you still can charge eVTOLs with multiple inlets off our 80 kilowatt chargers. But we're seeing eVTOL and even the larger fixed-wing aircraft gravitate towards this sort of 240, 250 kilowatts of power. And this is the 240 kilowatt with the crocodile arm to show you how mobile that can be. And then for some very high powerful 6+ seat eVTOL aircraft, they've asked for up to 640 kilowatts of power. And the way we're doing that is dual 230 kilowatt liquid cooled plugs that have optional liquid flow as well. So we can actually liquid cool the batteries off board. And the slight difference in architecture is up to 250 kilowatts. We can have no liquid cooling because of the high current rating of the GBT coupler. Thank you, China, for inventing that. And then the fact that the 640 kilowatt does need liquid cooling in the cable, we move all our DC hardware out of the dispenser and to stationary cabinets. So more similar to what you've seen with Tesla superchargers, having the dispensers, the little U-shaped cable holders, and then they've got DC conversion hardware in cabinets nearby. So when you're initially rolling out your infrastructure, you can just plug into AC connectors, run up to 250 kilowatts. You can run one on either side of the wing, so you still can have up to 500 kilowatts with very portable charging infrastructure. But once you've gotten to the point where you've got a multi-site like this, a 4 or more bay FATO solution, a fixed takeoff and landing area solution, then you want to start having all the hardware at the back end. So the types of layouts of charging inlets are either fuselage mount, where you want to just plug it straight into the fuselage. A lot of them are wing-based inlets, so you want to be able to get the charger around the back of where the aircraft's landed so that people can get on and off easily. And no matter where the inlets are in the aircraft, we've optimized our charging solution to still be able to come around. And bear in mind, there's a lot of variants. Like we've been keeping track. There's, 1,000+ designs of eVTOLs out there, maybe a dozen that are well funded. But even those dozens have different locations of inlets. So we have to be very agnostic to airframe to cater for these different solutions. We're seeing this is the most common for eVTOL, where they're wing-based batteries and therefore wing-based inlets. So we've designed our crocodile arm to bring this either 250 or 640 kilowatt charger around the back and then bring the cables up to the wings and still not obstruct either access of the doors, left or right of the aircraft. And even if that landed, plus or minus 90 degrees, nose into the wind, you'd still be able to have unobstructed access for the passengers. So it's really important to think about this ingress and egress and cable wear and tear. So I'll summarize in saying that we've really developed the most modular charging solutions on the market to be as airframe agnostic as possible. Starting with the 80 kilowatt, it's kind of our bread and butter entry-level charger. It's very portable, fits through a doorway. We can, for now, cater for CCS 1 and 2 for the stubborn US and European customers, but that allows them to then transition to 6968 in the future. So the dual 250 is coming out this year. We've already got a lot of reservation interest for that. The 640 will be next year, and then we'll continue supporting the industry with portable charging solutions in the future. So we do these containerized batteries to support the buffering of grids, as I mentioned. And this is the typical power bay of the back end of a charging solution. So you may have all these portable 640 kilowatt dispensers. Where's all that power coming from? It's typically not going to be enough power from the grid. So you're going to have one of these cabinets on the front left there for every one of those 640 kilowatt chargers. And then you're going to have a containerized battery for every half megawatt to a megawatt of power you need. In this particular site, there was only a half megawatt grid connection, but they needed up to 3 megawatts of peak power to deliver up to 640 kilowatts on 4 bays, plus all the air conditioning loads and the other operations at the airport. So that's the example solution. So in summary, our goal is a technical leadership and 100% customer satisfaction of chargers. We can't just use car chargers. They're not going to be reliable enough. They're not going to be practical enough for the high cadence operations of commercial aviation, and especially eVTOL. And even the fixed-wing operations, we've seen operating our 3 two-seat electric aircraft in Jandakot Airport in Perth, Western Australia, for over 6 years now. You just have to be ready to move the charger up wherever you can park it. You might have a very busy apron of commercial flight training, and there's half a dozen aircraft in the way of where you want to charge your electric aircraft. So you have to bring the charger up to the aircraft. You can't expect everyone's going to move out of your way to get your aircraft to the charger. Great, so not letting me skip the next solution. I think that's the last slide. So thank you very much for your interest in what we're doing. Feel free to reach out and have a look on electro.aero for more information. Thanks.
Thank you for your speech, Mr. Potlock. You are an inventor and also a very smart person with the sense of business. The e-flight development has a lot of opportunity in terms of the business. We saw some converted from the automobile industry. Indeed, there is a major difference between the car and airplane, including charging. You mentioned about the portable solution that is important, including the drones and eVTOLs. We need to try to resolve this issue. It's not only about aircraft and the solution. We still can find some opportunity in business. So we have the aircraft, we have the charging, about the takeoff and land. So the forum covers a wide scope of topics. Our next speaker is the Long-Rise Avionics Vice President Zheng Zhaopeng. The topic is focusing on independent and controllable avionics, jointly building the new ecosystem for the low-altitude industry. Let's welcome Mr. Zheng.
Well, ladies and gentlemen, thank you very much for your patience and finally getting close to launch time, right? And my name is Zheng, the Vice President of Long-Rise Avionics, and it's a great honor to be invited to deliver this keynote speech. And our head office is located in Hangzhou. It's a very beautiful and historical and innovative city, and want to welcome all the distinguished guests coming visit. This year marks the 5th anniversary of our company and is the conclusion of our first 5-year plan. Over the past 5 years, we have collaborated with major aircraft manufacturers and airlines and ecosystem partners to accomplish many interesting initiatives like developing the world's first 5G wireless quick access recorder, and our ELT emergency locator transmitter has also successfully passed coast passing certification, and is set to become the first beacon product in China to achieve dual certification, both CTS-08 and coast pass. So we have thus made a small contribution to reducing the costs and improving the efficiency of the civil aviation. While compared to many enterprises and institutions present here, we still have a long way to go. So today I would like to share some preliminary thoughts to spark further discussion, and look forward to collaborating with all of you to have more connections in this low altitude industry. Thank you very much. 各位嘉宾，中午好！因为我们在场呢还有很多不少的这个外宾，所以刚才简单打个招呼。那我是
Now I translate to Chinese. I'm from Long-Rise Zheng Zhaopeng.
公司呢是致力于
Our company is dedicated to get the onboard avionics, and so we're a supplier for avionics. It is my honor to share with you on this topic. The agenda of my speech, 3 parts. First is about industrial background. Second is key progress as the onboard supplier for equipment in terms of R&D, some of the progress and practices. The final part is the future prospects. From the right side to the 2 pictures, you may see that in the past 2 or 3 decades, the global aviation industry, despite of the economic depression, terrorism and SARS, the financial depression, and there is a major gap between the 2020 and 2022, namely the COVID. The civil aviation still maintained resilience with 0.9% compound growth rate. According to the prediction, the global civil transportation volume of passenger will maintain the 4.2% of annual growth. In the next 20 years, and China is expected to become the world's largest aviation industry, accounting for 20% of the new airplanes, more than 10,000 fleets, and for the trillions of yuan market, with the guidance of the market to play the role of scale of the economy, proposing some imagination scope. For the onboard equipment as the main function, realize it for the aircraft to ensure the safety of flight and also the performance. It is like the brain, the neurons, and the limbs of the aircraft. The avion onboard equipment accounts for 35 to 40% of the total value of the aircraft, including air control, avionics, and propulsion, the electronic motor, and some subsystems. For the onboard equipment is mainly dominated by the foreign companies. I listed the revenue from the top of the avionic companies for GE, Honeywell, Infinix, from billions of US dollars to hundreds of billions, by the M&A to improve their core competitiveness and also the bargaining power, and also by the cooperation with the whole supply chain, for instance, OEM, airlines, and to build up ecosystem partnerships. Gradually, there is the OEM-based and the integrated, the specialized supplier, and by this organization methods, on the one hand, they can build up their moat so that ensure they get monopoly in the market. What's more, by the professional division of labor, they can improve the efficiency of operation. It is worthwhile for us to learn about the low-altitude economy as the emerging trillion-yuan platform, and with the coordination of national policies and industrial development, there is explosive growth. According to CAC, in 2025, the market scale will be like 1.5 trillion, 2035, 3.5 trillion for the LAE. For application scopes for traditional GA to the LAE plus fusion industries. Opportunities there, so does challenges. In the past 2 days, we talked to many participants. For the eVTOL industry in China is still facing some challenges. For instance, the airworthiness regulation, technology constraints, and constraints in commercial methods. For the review of the new aircraft, the CAAC airworthiness practices require efforts of all parties.
Also, the methodology of airworthiness certification. Also, in terms of technology, we also have a long way to go, including weak efficiency in battery intensity, heavy reliance on imports for high-end components, and weak low-altitude information network coverage. In terms of application scenarios, we have only carried out pilot programs in typical scenarios, and eVTOL could only serve the niche markets at this moment, and companies involved in the sector are generating loss. Most of them are like that, and they need to make significant investment in technology, and there is a long payback time, and the market has not established a stable demand yet. Customers' acceptance is also low, and concerns about noise and safety remain unserved. Right now, focusing on the avionics field, we still face several challenges, and here I've summarized these as 3 highs, 2 losses, and 1 low. We face greater challenges in this area, especially in terms of the stability of the aircraft equipment. We are still lagging behind, and these are the challenges we need to overcome. Also, right now we see lots of international big names monopolizing this industry. If we want to make any breakthroughs, then we definitely need to think about how to lower the R&D cost, the manufacturing cost, or rather the entire supply chain cost. And all of these rely on scale of economy, and we need to solve these issues. So to summarize, in the first part, well, we talked about the the future and the challenges. Well, the future is promising, while at the same time we face lots of challenges. So how should we respond to these challenges? So next, I'd like to share with all of you our practices in the last 5 years. We have learned our lessons and gathered some experience as well. We have established the first aviation technology development center in Zhejiang, and we are the only provincial level private non-enterprise in the aviation field. It is dedicated to creating a new generation of aviation reliability verification platform with integrated capabilities in design, manufacturing, testing, and maintenance. Currently, comprehensive and professional testing resources are relatively scarce in China, and many of our company's avionics equipment must be sent to foreign labs for airworthiness testing. And that is why we have invested billions to establish a national level aviation technology verification center. In this field, based on CMA and CNAS and AS 9100 requirements, we have established a standard compliant and end-to-end testing and EMC design and correction services. So far, we cover the 0160G, AS 9100, and GBT, and etc. And the test items cover environmental endurance, such as extreme temperatures, humidity, waterproofing, icing, sand, dust, mold, and salt spray. Operating environment endurance, such as crash, shock, vibration, acceleration, flammability, and fluid susceptibility, and also EMC categories, such as voltage spike, stake discharge, and etc. In airworthiness, we also offer consultancy services covering the entire process, from compliance planning, technical documentation, preparation, and compliance testing to final certification. This helps our clients to efficiently get their certifications. And secondly, we have established a self-learning digital platform. We have also been awarded the designation award of a provincial industrial design center in Zhejiang. Our platform aims to provide efficient and systematic industrial design support for domestic avionics products, speeding up the replacement of critical equipment with domestic alternatives. We have also gradually established integrated design process covering conception, modeling, simulation, and data management, etc. Also, in recent years, we have served quite a few leading customers, including Comac, China Eastern Airlines, SF Airlines, and Hainan Airlines. So we have developed a new generation of smart manufacturing models. We now cover over 100 different areas, and all of these areas are connected, covering altogether 10 disciplines, 1,000 design activities. Also, we have carried out practical activities in the simulation field, cutting the simulation time by 50%. Also rely on natural language processing and other AI technologies to build a smart self-learning MFG process. The entire process can be converted into a structural process, and we have also increased the efficiency of documentation preparation by 45%. We have also built a flexible production line and greatly enhanced the reuse of assembly line. Also, the scheduling time can now be shortened from hours to minutes. Also, a smart inspection. We have developed a quality full life cycle management platform covering 10+ inspection scenarios, from the spool, the smallest component, to the entire product. We can cover the entire life cycle, and the inspection efficiency has been increased by 50%. The last is a smart operation and management. We support 724 safeguarding, and also we support a wide range of OM scenarios. We also provide after-sales services to customers. And so far, we have provided services to over 20 airlines, and also we continue to update our electronic menus, continuing to safeguard the flying safety. Finally, I'd like to talk about the future prospects. Focusing on the upstream of industrial chain, we have cultivated a group of industry suppliers to transition and upgrade into the aviation sector. So far, according to our own statistics, the industry suppliers, they previously are not that experienced in aviation industry. So in the last 5 years, we have grown together with these industry suppliers, together gaining experience and empowering these industry suppliers. Also, we help them to establish AS 9100D aviation quality management systems, help them design assurance systems and airworthiness testing capabilities. And so far, we have already got a solid pool of suppliers for both large aircraft and low-altitude industries. We hope to extend avionics manufacturing capabilities both up and downstream in the supply chain to enhance efficiency and reduce cost. And in terms of the downstream, we are developing a series of demonstration scenarios. For instance, our independently developed 5G WQAR flight data recorder is helping airlines with optimal domestic solutions. With the 5G advantages, we have significantly increased data transmission speed, reduce latency, and expand data storage capability. And we could also use cloud edge and a collaborative architecture, and data can now be in a smooth circulation, and we can make sure it is real-time simulation, and we can trace anything in the past and predict things for the future. We have also developed the country's first emergency locator transmitter that's about to receive due certification from CTSOA and COPAS. We have also made breakthroughs in technology, and it's also allow long life durability. And it could also effectively solve problems of trigger accuracy and ensure that in extreme conditions such as impact, crash, and fire, and the device is also both lightweight and offers super high-strength structural protection. Also, our ELT products have been serially developed, including first generation with AF functionality and second generation with DT functionality. And it is now becoming the top choice, and they are already installed in various prototypes to assist clients with certification. We have also worked with airports to develop management systems addressing issues such as single modal control and significant wasted lighting for high-mast lights. And first of all, we account for energy-saving lighting control in specific apron scenarios, quantifying multi-objective data such as ambient light, flight status, and visibility conditions to dynamically extract state perception features for energy-saving control. And we will see that the entire industry becoming a trillion RMB worth industry, and we're willing to provide smarter, greener, and better products to the industry and make greater contributions to the digital transformation and high-quality development of the civil aviation industry around the world. That's all from me. Thank you.
Fastest talking.
And yes, our next speaker is a totally different area, but also something which is very important if we want to have eVTOL and low altitude economy working, because we're talking about the business case having aircraft flying on a regular commercial base. Means it's depending on the weather. And what means weather? In aviation, we know from the beginning that there is icing which really can affect your flying, which will stop you or cause accidents. So that's why there has to be new de-icing solutions for this new class of aviation, I believe. And that's why I invited my old friend Marcus, who is working in this for years. Marcus, stage is yours.
Hello, everybody. Nice to be here again, a year later. Just before I start my presentation, I would like to point out that right now I have a presentation about our ice protection systems. And we also have a presentation a little later, 2:45 in the other room, about heating systems, highly efficient heating system, which should be interesting when there is manned flight for eVTOL and similar. And there's another caveat here. The presentation I show is actually not the final version. It's still a draft somehow. Even it should work, I think, because the final version I tried to load up this morning and it was too late. So anyway, I apologize for anything which doesn't look too great on that one. Okay, so what are we doing? We do, for more than 20 years, we do some unique ice protection systems for different types of aircraft. Unique means we are beyond what's state-of-the-art, because state-of-the-art in many, at least for eVTOLs and things like that, doesn't work very well. And I will go into that a little deeper later. So we do ice protection systems, and more so we also do ice detection systems. You have to detect the ice before you can take measures, of course. More so if something is flying remote, like a UAV, you need some way to censor if there is ice, you're approaching into ice or not. So we do ice detection, ice sensors, and ice protection. Yeah, we are certified EASA and FAA for production. So next slide here. Okay, now ice. A lot of people don't think about ice really much, but when you fly, you encounter it all the time. And I have here this graph about frequency of icing conditions in Asia. And as you can see, there's quite a lot of ice in some areas. I mean, you don't find it down in Shenzhen or Hong Kong, probably. But anyway, a lot of other places more in the north, you will find icing conditions. And if you go commercial with your aircraft, as long as it's private, you don't fly when there is icing issues. But if you go commercial and you have a time schedule, then you really have to deal with ice protection and ice detection. And ice formation on an aircraft, no matter which kind of aircraft, is a serious threat. And actually we found just recently, I mean, it's actually for longer than recently, for some years, that eVTOLs, copters, are very delicate against ice. Very, very dangerous situations occur. So what's the big deal? The big problem is, first of all, if you're getting ice on the rotors or propellers. And you don't need to fly into snow or in really hard conditions, just fog. Freezing fog. If you fly into foggy conditions, which is below, or let's say it starts at like 5 degrees plus, and then of course down, you can get ice on your leading edges of your propellers. And there's quite a lot of events, and if you find it on the internet, there's quite a lot of crashes, and people don't know why they crash. And the reason is that they got ice in their propellers, and they get unstable and, fall from the sky. There was a test in an icing tunnel a while ago in Canada, where they tested multi-copters up to 25 kilos, different ones, lighter ones up to 25 kilos. Why not bigger ones? Because they don't fit in the icing tunnel. So this was the limit. The icing tunnel was the limit. And a lot of them crashed after 20 seconds or so, and one really survived for 2 minutes, but then he crashed too. So be aware. Now, why is it so dangerous? It's because when you get ice on your propeller blades, and normally, as long as it's a rotating one, it forms on the leading edge, okay, on the front where it cuts through the air. And you see here on this graph, you see a test we did in Vienna some time ago, just how much you lose on performance when ice accretes. This means it was, you see the blue one, 1500 RPM, and here you see the timeline on this graph. And let's do the 2500 one, within 2 minutes, you need a lot more than double or triple the power to just keep the same hovering, just to keep the same RPM on the propeller. And actually, it's just one of the problems. So one of the problems is the aerodynamic losses. You need more power. Another problem, you lose lift. You lose the aerodynamic lift, which keeps the airplane in the air. Another problem is you get unbalance and vibration because the ice falls off sometimes and the whole thing vibrates, and it increases weight. So this is what happens, and this is what makes you crash. On the lower pictures, you can see how the ice forms, just a few pictures here from testing. Okay, now what are the measures? What can you do against it? So as I told you, one of our product line is ice sensors, ice detection systems, and we offer one type in the moment. We're working on another much smaller type, but also this is pretty small, which we designed for aircraft, for bigger aircraft, but could be used on, let's say, a little bigger eVTOLs as well. Maybe not on the very small ones. The next generation will be able, for the very small ones, it's only 2 millimeters big in size. Now this is a little bigger, about 3 centimeters or so. And what it does, it warns you when you get into ice. So if it's a piloted aircraft, you use it when you see it to activate your ice protection system if you have it. Now, anyway, if you get the warning, there's 3 things you can do. So if you're flying an aircraft without ice protection system, land. Just go to land as soon as you can, or turn around, get out of the ice, or activate an ice protection system if you have. All right. So you see up the graphs up here, how this thing looks like and works, and this is our company test aircraft down there, where we do those tests. Now let's get into ice protection. We have 3 different types of ice protection systems. We have an electrothermal one, we have an electromechanical one, and we have a new one for small multi-copters as well, which is fluid-based. And the electrothermal is the E-tips, electromechanical EMIPs, and FIPS for the small ones. And we can offer, every ice protection system has its pros and cons, like always. And we choose the right technology for an application. Okay, now this is, because it's a draft, on the whiteboard there should be a video, but we weren't able to load it up, as I told you. Now, this is about our FIPS, our small multi-copter ice protection system. What you see on the right side here, the power you require is the red graph. Without an ice protection system, and you see the seconds there. And the blue graph is with our ice protection system, which is actually a de-ice system. So it always makes a little bit of ice. You see where it goes up, you need more power. It de-ice, it goes down, up and down, and up and down. But it always keeps you in a safe flight mode. Without ice protection, you would crash. Okay, so now, this is just, we do other stuff besides small aircraft. This is kind of shows a few examples of ice protection systems we do for different types of aircraft or parts. We also do air intakes and pitot tubes and, whatever it's necessary. All right, so we're kind of a place where if you have a need for de-icing, we can do it from the beginning to the end, everything you need for ice protection. Thank you very much.
Thank you, Mr. Willinger, for your speech, providing with us really good the eVTOL ice protection and the heating solution. Thank you very much. The last speaker in the morning session, the Heavy Link Automotive Electronics Company Limited, Director of Certification Configuration, Mr. Wen Wencai. The topic is Progress High Volt E-Propulsion VTOL. Let's welcome. Distinguished guests, dear experts, good morning. To start with, I want to thank e-flight-Forum for this opportunity for exchange. To start with, about myself, I'm from the J-Link, the airworthiness configuration director. I worked in the COMAC for more than 10 years, participating in the airworthiness and R&D of C919, C929. Because there is some issue in the supply chain for the large aircraft, we hope that e-flight will not encounter the same issue. I myself now is dedicated to the e-flight supply chain. The topic of my speech is for the J-Link in terms of the silicon carbide stick, the eVTOL high voltage motor system. The power system determines the transportation. In recent years, and we've seen the prosperity of the eVTOL, providing some opportunity for the development in distributed power system. For LAE, it's opportunity for us. In terms of the eVTOL e-propulsion, we made some deployment, having some capabilities and making some progress. I want to share with you in more detail now. To start with, about the LAE ecosystem. LAE refers to the 0 to 1,000 meters airspace for eVTOL and the UAV development. For LAE is saying busier traffic with larger scale. The potential is huge. More companies are now joining into the LAE ecosystem. The eVTOL system involves a lot of participants and links, and for instance, manufacturer for the aircraft, the parts and components, integrator, the infrastructure, regulator, testing, verification, institutions. In the supply chain, upstream, the core is the e-propulsion battery flight control. For e-propulsion, based on a group standard, according to the requirement, the e-propulsion refers to the 1 or 2 motors, the controller and cables, the monitors, propellers, they can convert the electricity to mechanical force. To put it simply, the E propulsion refers to the motor and the propeller. As the key drive in e-flight, it needs to meet multiple standards and regulations. For instance, AS9100D, airworthiness, configuration management, RTCA, DO178C, DO254, etc. Compared with traditional battery for EV, the e-propulsion system requires higher power density and higher efficiency and response speed and higher reliability. More details about the electronic engine requirement for the civil products and components requires the certification and the from the CAAC to get put into operation. So for the eVTOL, the motor, e-motor, there is no specific requirement. But in 2024, the CAAC issued the e-propulsion system condition guideline. The document is by now the most authoritative CAAC official guiding document involving the e-propulsion system airworthiness. It's mainly applied to the e-motor and the propeller, the type certificate review, and also the reference for the engine review in aircraft. So now we need to meet the guidelines of CAAC about airworthiness. As for airworthiness requirements based on the CAAC regulations, for components and parts, including the onboard system, the airworthiness, there are two pathways. The first one is independent, the second is the random certification. Independent means that the manufacturer gets certificates to apply and get the label from the CAAC. The random certification means that the part manufacturer, as a supplier, they don't take responsibility for airworthiness. At the same time, they don't have the rights. So the parts and components need to be labeled by the certificate holder. They cannot sell directly to the market. So the most of the onboard system with the OEM to get a random certification, in the world only Saffron, they got the EASA TC.
And we hope we could provide the independent certification process for propulsion systems so as to accelerate the process. This is the independent certification process. For electric engine, this is quite similar to traditional engine. You need to get AC and PC as well as TC. The specific processes are demonstrated on the CAAC website, so I won't go on the details here. This is about the type management and configuration management. This also plays a key structure, and configuration management is critical because you need to make sure they are compliant. So we need to have a very strict configuration management, and that requires a systematic process, methods, procedures, templates, and etc. All need to go through the assessment so as to ensure continuous consistency and compliance of customer requirements. Moving on to talk about safety. Safety is #1 priority, especially for passenger carrying aircraft. And we also need to make sure we are compliant with all the requirements. And in this regard, the core requirements are Section 25.1301 and Section 25.13 1309. They are to ensure that aircraft systems and installations can operate normally in their respected environments and that any potential hazards are controlled within acceptable limits. And this is section XXX.2510, and it provides requirements on systems, equipment, and installation. So unless otherwise specified by the standard, every system, equipment, and installation of the aircraft must meet the following requirements. The likelihood of catastrophic failure state is extremely low, and they are not caused by a single point of failure. And the probability of each hazardized failure state is extremely unlikely, while the probability of each failure state is less likely. So for eVTOL, depending on the structure and the application scenario, the failure allowance is different, but normally is 10 to the power of -8. So normally this should be compliant with 6.1 or 5.4. Now we have a complex hardware and software being used in aircraft, so that means more areas for error and that require new verification methods. So a new set of guidelines been developed. And here we have 178B and 254 and 4754B. We developed these guidelines to minimize development errors in aircraft and onboard systems, including software and hardware. Moving on to talk about the requirements for product performance. For eVTOL, the driving system involves a number of technologies, including integrated technology. I just mentioned that catastrophic failure shouldn't be caused by a single point of failure, so that means we would need a number of integrated technologies so as to ensure enough power density, and also involve a complex control system and control technologies. Usually the flight would have 8 to 9 sets of control systems, and that would involve lots of interfaces, including main interfaces and monitoring interfaces and channels, and that involve complex logics and that require complex control system. And the next is thermal management technology. Thermal motors, they would generate lots of heat, so we need to make sure we have good enough thermal management technology. Also, another thing is EMC technology. We have a high pressure structure, and that would create a big electromagnetic field. To make sure that planes can run well and safely under such a EMC field, we need to have good EMC technology. Another is silicon carbon packaging and testing technology to cope with higher pressure and higher power. Also, silicon carbon could be used under 600 Celsius degrees. It has better thermal performance. So the development speed of silicon carbon is 10 times than the traditional material. So it's a good technology to be used for eVTOL electric propulsion systems. Given these requirements, we have done some in-depth research. First of all, a few words on the background of our company. Our company is called J-Link Electronics. And J Electronics is a wholly owned subsidiary of Jinlian Automobile Electronics. We started in 2022. Since then, we ventured into the eVTOL field, focusing on the research, development, manufacturing, and sales of aircraft power system. And it possesses abilities for independent forward development of the complete chain of power modules, motor controllers, and electric engine systems. So far, we have got lots of patents, and we have also worked with Aerofugia and GNC Automobile and carried out lots of pilot programs. So far, we have our products are being developed and tested and approved to be able to meet airworthiness requirements. We have independent development and packaging capabilities of silicon carbon power devices. The maximum efficiency of silicon carbon power module can reach 99.8%. Our silicon carbon power modules could allow low on resistance, low parasitic inductance, and low stray capacitance. Also, we have other products, including electric motor, electric control, and other reducer radiator, as well as other features. So it has good disturbance resistance, and it could also cope with complex structures. So this design means that our products could meet the DO160G, DO254, and DO178C requirements, as well as the AC-21 requirements. We also have a sound testing capability. We have a lot of labs covering environmental testing, vibration testing, salt spray, powertrain, power supply, and high-speed motor performance testing. Our lab has also been accredited by CNAS, and we can also issue reports stamped with CNAS, allowing for one accreditation and multiple certifications. We also have lots of avant-garde equipment, including a module die bonder, wire bonder, and module static testing equipment. Hence, we could accelerate the product development and iteration process. We also have strong manufacturing capability. We are able to produce 300,000 power modules, and we also have MCU production line, EDS production line, and we have also passed the AS9000 certification. We have nearly 20,000 square meters of clean room facilities, and all of these use state-of-the-art equipment. And we have also got full sets of relevant equipment and facilities, and we also ensure the entire production process takes place in closed-loop system within a dust-free, temperature and humidity controlled environment, and eliminating the impact of environmental factors on product quality control. We have also used the leading technologies, and the layout of the factory and the process is designed for precision and efficiency. Also, we manage the assembly process through intelligent and detailed quality control methods. We could also allow flexible production, and we use ERP system for interactive and visual management, ensuring the process is controlled and reliable. So, in terms of the design assurance system, it covers three functionalities: design, airworthiness, and independent oversight. In terms of design function, we could develop models according to the airworthiness requirements, and also we could help develop the airworthiness certification process, conduct compliance verification, and generate necessary documents. We could also address the deviations in manufacturing and accept concessions as needed. In terms of airworthiness functionality, we could establish the criteria, create a design assurance handbook, and participate in compliance verification and organize the documentation for it. And in terms of independent oversight, we could ensure independent oversight is designed to guarantee the suitability and integrity of fulfilling duties. And this is our configuration management capabilities covering engineering, manufacturing, testing, customer, and suppliers. So together, this generates accurate management results. In the fourth part, I'll talk about the key achievements in our R&D. First is the 800-volt silicon carbon dual redundancy motor controller. This is used in Aero Fugia aircraft, and we are now the strategic partner of Aero Fugia. This is the 400V motor controller, and is also used in GAV Gobi aircraft. We are also the only supplier for this Gobi aircraft for its controller design, development, and certification, as well as mass production. This is the 800V motor system, operating voltage 530 to 880, rated voltage 700 voltage. And this is the highlights of the product. We have an integrated design for motor, electronics, and cooling. We use then electric control efficiency is up to 99.5%. Also, we use carbon fiber for the rotor, wrapping the rotor. We have active air cooling. We have featuring torque estimation, 0-point calibration, LSC, junction temperature estimation, and sensorless algorithms. That's all from me. Thank you.
Because we're going to have the panelists. Please stay. And all the speakers of this session, please come up. Take your translators if you have questions from somebody else in Chinese. If there are enough microphones, otherwise there is one. Yeah, okay. Have a seat. Right next to one. You can sit in the middle. Lady. Or maybe. Okay, it's okay. I think we're fine here. So again, same procedure than always. I hope everybody has a microphone. I have one spare one here. And yeah, any question in the audience, please come up to the right-hand side and take the mic and ask the questions. For the moment, I have a question on electro-aero, Josh. The charging systems, I understand that you say, okay, for the aircraft, we need a different system than for the car. On the other hand, at the moment, it's just in the building up of the system. And, you know, being realistic, especially on small airports, when they are building up a car infrastructure now, would you have some connection points, so that, for example, you could also offer some combination, that you could also offer the integrated car support point, because otherwise they would have to have two infrastructures to be installed at the same time.
Yeah, we thought that might be an issue, especially in light sport, where there's at least a chance of cars being near where the aircraft are, but they're almost always on the other side of the fence, meaning there's always airfield and car park. So yes, they can run off the same containerized batteries and solar and energy sources, but the physical plugs will be on the wrong physical location. So you want those car chargers in the car park, and you want the aircraft chargers on the airfield. But yes, you're right about at least symbiosis. As you grow a vertiport, you're going to have people showing up with electric cars. So you want to be installing those car chargers at the same time. And what we've done in our dynamic load management system is prioritize the aviation charging and actually throttle down the car charging. So at our hangar in Jandakot, where we charge our electric two-seat aircraft, we only have like 40 kilowatts of grid power. So if we're charging one or two aircraft at the same time, there's no car charging allowed. So we actually throttle down the car charging when we're charging the aircraft, and then we throttle it back up again. So we prioritize turning the aircraft around.
Yeah, that's what I mean, especially when you have then this battery solutions, and they're not used for the flying at the same time, and so it would be useful not to have installed battery solution for the car side as well.
Yeah, so definitely behind the plug, the infrastructure side can be unified, but the plug side is very geographically different. It's car park versus airfield.
Okay. Question to Marcus. What about de-icing system? Because they consume energy, and we know energy is very limited on electric aircraft. So what if, I know that you work on some thermal de-icing system, also on the shakers. So what would be for an eVTOL the ideal solution? Let's say the solution would get you rid of the ice and consumes the least of energy and is lightweight.
Okay, like a long question. I try to make a fast answer. In fact, it really depends, because, and in fact, what you need for electrothermal de-icing when you have an eVTOL is really not that critical than it is for a combustion engine, you know. Conventional aircraft, they have small alternators, they have not much electrical power. It's a bigger challenge for them, I think. Still, you probably need, it really depends on the size. You need some power which can be significant. However, we have an electro-expulsive, you know, a mechanical shaking of the ice, which requires very, very little electrical power. It really runs on a big airplane with like 60 feet of span. It runs on 300 to 500 watts, so very little. However, it's a little heavier, and you cannot, for example, you cannot use it on rotors. It wouldn't work on rotors. It's just for leading edges. So for rotors, you need the electrothermal. But again, electrothermal on rotors has the big advantage that you have centrifugal force. You don't need too much electrical power. You need a lot more electrical power for electrothermal on a steady leading edge, you know, of an wing. Anyway, but there is a problem coming up for the lift and cruise kind of airplanes. You know, where you have lift rotors, and for cruise you take the horizontal ones. So in flight, the lift rotors will be standing still. And if you collect ice, it will collect ice everywhere. It can collect it wherever the ice just finds a spot to stick on. So you not only have, for landing, you need these rotors again. So in this case, you not only have to de-ice the leading edge, just like conventional rotors when they rotate. You may have to de-ice the whole blade, because it could be everywhere, you know. So anyway, this is a challenge we are just working on, and we think we have a solution, but it's electrothermal, probably.
Okay.
For the bigger ones, sorry. For the small ones, we use fluid.
A question on Margaret. You know, do you already, you know, how high is the percentage of international members in Llama? Just roughly. I don't need the exact figure, because we have here some manufacturers from Europe, but we also have Chinese manufacturers, as we've seen over the last 3 days, especially with the event on Friday. There is a great dynamic here. So when developing standards, probably would be good to have as many Chinese on board as possible.
Absolutely. We have quite an international group of folks. I would say, maybe 40% are international based. We do have a couple of members that are from Asia, and we want more. So please, yeah.
Okay.
Look at it.
Question to the gentleman. I always have a question
You
here.
have a question, yeah.
Okay.
Yes, I have a question for Josh. So, what do you think the electric aviation chargers and the distinguished difference between electric aviation charger and electric vehicle charger, and how is electric aero going to contribute, worldwide charging standard?
Sure. So I'll re-emphasize that portability is critical for aviation, especially the eVTOLs, where you don't want to waste time taxiing, especially because you usually can't justify having wheels on them. So if you have to do a powered taxi, that's really power hungry. And as you know, they're very critical battery performance already. So you want to land, bring the charger to the aircraft, as opposed to a car you can just park right next to it. And that off-board liquid cooling is the second aspect, being able to liquid cool the batteries off-board. So bringing the charger and the off-board liquid cooler to the aircraft, get the battery charged fast while you're getting people off and getting people back on, getting the charger out of the way, clearing that 50-foot zone for takeoff again, and that's going to get these commercial operations viable. And then second point, just to touch on the fact that Electro Aero don't expect to be able to sell many chargers to Asia. Let's be honest, you guys are leaders at doing electric car charging, but we do want to at least encourage the Chinese manufacturers to adopt the SAE International standard, which is physically the same coupler. So there's nothing challenging about accepting the standard, other than accepting the software standards that SAE International are standardizing. Because that way, when you do ship your aircraft internationally, they're already ready for SAE standard, and we can really ensure compatibility internationally.
Okay. I would have a question to Mr. Su from Baidu. Your network, what you were suggesting there, which is an existing network, as I understand, what is for what the Baidu network is used normally? What other purpose does the network have? And is there still enough capacity to integrate aviation in this scale as well?
For the Beidou Fuxi system, the core is to serve the urban managers and for the government to provide the public service, to get the macro air control and also the micro service control. That is a system. So the management rules and control rules is dependent upon the national departments, for instance, air control, and also the CAAC. Based on these rules, and we implement our services and to get to the airspace management. So for the Beidou Fuxi, the system, it is mainly about implementing the will of the government. So for the local government with the authority to manage the airspace and how to develop the low altitude space. Currently, that is the resources. In the future, it is the medium height airspace, in particular above the urban areas, because in urban areas, the environment for flight is more complicated, so that we can get the orderly, controllable flight process. Compared with the Beidou satellite navigation, Beidou Fuxi is a software or management system. It adopts the positioning function for Beidou satellite. Thank you.
So it would be just a technical question. Is this only the satellite which is adopting, or is also integrating cellular network like 5G, now upcoming 6G?
Yes, indeed, including the communication, navigation, monitoring system, as well as the meteorological system. All the data need to be integrated into the system to have the unified grid-based calculation so that we can analyze that in which region now and in the future is available for flight, so that we can get the planning for routes to acquire the information.
And would Baidu also try to offer these services in other countries, or is this China only? Like I think Baidu is also...
Currently, Beidou Fuxi is exporting technology solution to other countries.
Okay. So yeah, we still have one question, I think, before lunch. Let me see. Yeah, more or less, because they give very precise figures. 32. Okay, great.
Actually, this question also for Josh. Since you know, from our data of a EV application, for the safety concern is charging process is the most risky process. I'm not sure the charging, especially fast charging, is the solution for electrical aviation. I'm not convinced, because for our battery in the future, we want to have a certified for battery system. The good thing for that is if you have battery system offline, you can do health check every run before you flight. But on board, maybe that's not easy. But yeah, I want to hear your opinion on that.
So over the decade I've been in electric aircraft, and actually 2 decades, including unmanned, in manned aviation, the weight optimization is so sensitive that swappable batteries are actually far too heavy by the time you factor in that you actually want the batteries part of your structure. So to take them out every single flight is just not economically practical or safe. So there's more dangers in removing batteries from structure every single flight than fast charging them. So what's more important is that off-board liquid cooling and making sure that that's all operated in symbiosis to ensure life cycle of the battery for the economics. So just to explain that in a different way, if you just fast charge batteries, you're right, they would not last long enough. And we've seen that in our Alpha electro-aero operations in Australia, when we were initially running them every single hour, fast charging them every single hour in 40+ degree ambient weather, the batteries were not lasting long. And these are, you know, fairly mature cylindrical automotive cells. So since then, we've done off-board cooling, especially in summer, just air-cooled for those aircraft, but then liquid cooling for our eVTOL customers, and we've achieved over 1,000 cycles. So gone from less than 500 cycles to well over 1,000 cycles with active cooling during charging. So with that active cooling and making sure you're throttling down the charger if they get too hot, so that closed loop of making sure you're protecting the batteries every charge cycle, which is mostly done off-board. So even though the batteries are still on board the aircraft, all that smarts and all that cooling hardware is on the ground. So it's not as weight sensitive and can be really optimized for performance. Then you can get up to those 1,000+ commercial flight hours and get the economics to justify fixed batteries with fast charging.
Okay. Another question? Okay.
Yes, thank you. For Margaret at Llama, it's obvious that your impact with the association has made Llama stronger and affected the regulatory environment in the United States. I was wondering, though, as a part of understanding the industry, have you flown various models of light sport aircraft? And if so, what's your longest flight?
Yes, my longest flight was from Texas to out to California in a torpedo, which was a lot of fun. A little two-seater, and yeah, so it's great. I'm not sure if I answered your question, sir, but
And then you've flown in other models as well, I presume.
oh yeah, certainly. I've spent lots of hours in a Jabiru, and yeah.
Well, thank you. It's good to know that those that are working with us are actual participants in the industry versus just doing administrative and operational work. Thank you all.
I would have a question on our first speaker, Mr. Tian. I saw that you're talking about this a lot, about this infrastructure, about separating airspaces later, maybe connecting them. And I have had speakers talking about same subject here in China from different regions. So is there any kind of national coordination, like air traffic control normally is, or unless up to now, has been a national organization in most of the countries. Now with eVTOL very often, or with the small drones, there are local organizations in urban space. But having the same or a similar systems developed in 20 different cities, like China is very big, in 20 different cities, will probably not be as effective as it could be to get it done.
Thank you very much for the question. In terms of separation, the common consensus right now is to separate airspace first and integration later. This could ensure overall safety and the growth of both sides. That's a consensus. We have gained enough experience. And once we gain enough experience, we will integrate the new format with traditional airspace. This is a stable and safe manner. So far, we are still at the starting stage, and governments across China are actively participating in this course, guiding relevant players to behave properly. Eventually, we will definitely have industry-level government-backed associations or authorities giving out policies or guidelines. Right now, as long as it does not involve passenger carrying, the policies are still relatively loose or not that strict, but certification are the same as the US and Europe.
Okay. I think as we still have 2 panels in the afternoon, and we still, even just to remind you, we will have separate panels in the afternoon, like a finance panel in the other room, and here the panels on AI, which we already touched in this session here, because we've had several speakers speaking about AI implication. And so if you're interested in this, you will definitely hear more after lunch, and I still want to leave you a little time for lunch. So thank you very much.
好，谢谢。咱们上午的论坛
All right, thank you very much. Let's conclude the morning session, and we'll start from 2 o'clock in the afternoon. The main forum will still be here, and lunch is served on the 2nd floor, same place as breakfast. So see you at 2.
Over here. And the afternoon, the meeting time is 2 o'clock.
我也加，我是现在的客户经理，我也加微信。你跟我们肖总了。啊，对，那么这个我也留给你，我们一个最新的技术。哎，对对对。
Thank you. Yeah. Thanks for finding everyone for us. It's hard to
Yes, hello, Christian. Maybe we're just doing a little try now. If you could switch on your microphone, we'll try to, and your camera, we'll try to put you in the screen. We're in the break here, just for trying out if everything works. Yes, perfect. We see you on the screen. Hello, Christian.
Hello, Willi. Hello, Willi. Hi, nice to see you.
Nice to see you.
How about the audio? Audio is fine?
Audio is perfect. So if you could share your screen and the PPT so that we see if it works.
Yep, 1 second. So.
Yes, okay, perfect. Runs like this. So now we put you off screen again, and I just changed your name tag that the name which is on the right hand side will be correct.
Okay, perfect.
Okay, thank you. See you later.
Thank you. See you.
好，请大家落座。咱们那个下午的论坛开始啊。那么在开始论坛之前呢，我们在论坛开始之前，我们先要插播一个环节啊，就是我们有一个签约仪式啊。这个实际上是我们论坛最愿意看到的这么一个场景啊。咱们论坛其中一个非常重要的目的，也是促进咱们业界的合作啊。所以我们今天有一个很高兴有一个签约项目。签约的项目是那个电动航空适航机能源管理系统开发，签约人是上海拓飞航空科技有限公司 CEO 陈开明先生，安徽蒙威新能源科技有限公司 CEO 周丽莎女士，请两位签约人上台。同时呢，我们有两位见证人也请上台见证我们的签约，一位是投资人代表郭洪生先生。第二位是安徽蒙威新能源科技有限公司创始人张月刚先生，请上台。那么双方将聚焦电动航空适航机能源管理系统的研发与应用，以蒙威科技在新一代高比能电池领域的深厚积淀，结合拓飞航空在电动航空系统集成方面的卓越技术，共同开发符合航空级安全标准的高性能能源解决方案。所以有请双方签字签约。好，那我们祝贺双方的成功签约，预祝双方在未来的商业合作当中取得成功。你们这个合影留个念。好，谢谢，谢谢，祝贺。那么接下来我们下午的论坛开始，有请Willi来继续主持我们下午的论坛。你好。
So as we are cleaning up the stage here, we are going to start our afternoon session. We start with a little bit change in the program. It's only a 10-minute change which we'll have in the program, and this will be, except this signing ceremony. Yesterday and in the supplier session and this morning, due to the time difference, we could not have one of our speakers, which I really wanted to have in the hydrogen session, because it's another approach for hydrogen. So now we have Bosch General Aviation, Christian Grimm. He's CEO of Bosch General Aviation, and he is, it's going to come up to the, yeah, it's on the screen. So Christian is on the screen. Christian, the screen is yours.
Thank you very much, Willi. Thank you very much also for changing the agenda slightly. I would like to highlight what we are doing in the hydrogen as a Bosch group, and in particular for the aviation propulsion section. Here you can see our animation about the 916H2. So this is a conversion of an existing aviation engine to run on 100% hydrogen. We as a Bosch group, we are addressing the complete life cycle in the hydrogen economy. We are producing solutions on the complete path of hydrogen, starting from the production to the transport and using then the hydrogen in the mobility sector. For example, the PEM electrolysis fuel cell and also the H2 engine. My team and I, we are searching for a solution which are fit for the aviation use and CO2 neutral mobility. Therefore, we have checked which kind of powertrains we can use. Of course, battery electric, fuel cell electric. There we also have activities in the market and also are working with partners to bring that powertrains into the market of aviation. But in that particular case study, we have focused on how about the hydrogen engine. Therefore, we started the 916H2 innovation project. You can see here on the right side. Our competences are, of course, derived from the broad field the Bosch Group is offering. We have already proven track record on hydrogen engine electrification and fuel cell for passenger cars, light duty vehicles, off-road, and also sports, race cars, and luxury cars. And that proven experience, the products, the services, the solutions, and the technology behind, we have chosen and taken and combined to use it for other applications. For example, stationary engines, rail, aviation, or the maritime sector. We have focused, or we will focus now also in the marine sector. We decided to pick and choose a reliable, already existing, available, and certified engine. Our solution for that study was the BRP Rotax 916 IS engine, which is the most powerful engine in the Rotax lineup. But we would be able to use any engine, nevertheless, if it is a gasoline or if it is a diesel engine, as a basis for such an activity. Here we used the 916 IS. To be capable to run on hydrogen, we have to modify that engine. What we did as a modification, you can see here in the left top that, of course, the injectors, the standard injectors are not capable, so we have picked and chosen out of the Bosch product portfolio our H2 injectors. We have used separate spark plugs, and also the ignition system was changed. And of course, to bring the hydrogen as close as possible to the combustion chamber, we had to modify the intake manifold with such gas guiding tubes. Then some optimizations on the engine needed. The base engine doesn't include a camshaft sensor, so we have to retrofit the camshaft sensor also out of the Bosch portfolio. And we have installed some additional sensors which are needed for the test bench operation to have all the necessary data available at the end of the project to showcase the performance of the system itself. We have incorporated and installed the engine, which was up to now not at all at the test bench within the Bosch Group. Also, we are not the mass production supplier for the engine control unit, so we have to change it to a prototypical engine control unit. And we've installed everything in the in-house test benches we utilize and run the engine on 100% hydrogen. The complete process of having the engine in our premise, making all the engine adaptations by bringing our expertise to the modification, took about 3 months, and then we had a 4-month plan with a few days of testing and calibrating. And at the end of the day, we were really, really happy, and also our expectation we achieved to overachieve. Due to the hydrogen and that the hydrogen is displacing the oxygen in the combustion chamber, we were expecting a slightly or a significant power loss. But due to our optimization based on the know-how we have with the calibration engineers, we have achieved nearly the same power output as the core engine with the core configuration running on gasoline. So in the idle mode, we have achieved 100 kilowatt. The core engine has 101. And with full power, we have achieved like 115 kilowatt compared to the 117 the base engine has. So we totally over achieved the set targets. And this is making us very, very promising and very, very open-minded that this could be a viable product after a certain period of time for further testing and investigating. What we have seen is that this is an engine which is running on 0 CO2. Of course, we have to further optimize the engine. For example, there are some NOx as a residual emission, take care. But also here there are mitigation measures available we can introduce. And of course, the engine has to be optimized for the performance, the reliability, and also the efficient operation. The consumption of hydrogen we have to further optimize. What we have seen is that if we take automotive-based technology, for example, the engine controls, the sensors, we're able to speed up the development of sustainable propulsion system. And this is what we can use all powertrains, not only for hydrogen engines. What we also learned is if we have an existing aviation engine as a basis, which is already reliable, available, we know all the relevant certification basis requirements, and the hurdle is getting significantly lower to use an existing available technology and to make it sustainable, so CO2 neutral. The next step is what we have not included was the H2 storage, also the aircraft integration. Here we're looking for partners who bring storage expertise, the storage know-how and products, and also the capability for the aircraft integration into the next step for this project. Our target is to achieve the same power output as the gasoline version. Also reduce the emissions, reduce the consumption, and how we will do that. The next step will be an optimized injector, where we have a product which is developed in-house for hydrogen engines. We will optimize the combustion. We will install a slightly bigger turbocharger to get a little bit more air into the combustion chamber, and then we are sure we will achieve the same power output. And the next step is we are engaged in some discussion to have a proper aircraft installation, also including H2 tank installation, to evaluate this system in an aircraft, in a rotorcraft, or in other installation. What we are tackling as a Bosch Aviation, and we are in the market since more than 15 years, we are helping our partners from a prototypical proof of concept to realization phase. We help to manage the innovations and the latest technology standards. When we are using in-house products, then of course they will be produced in high quality series as so-called commercial products and manufacturing services. And as shown in that particular innovation study, we have a lot of experience, expertise, know-how, and smart people in our teams to make this happen and realize, for example, such a project. So our conclusion for the 916 H2, we called it engineered for change, is that the concept is viable even with the reduced engine modifications. The powertrain installation is similar to already existing powertrain installations. The performance is also on an acceptable level and can be optimized that it will be on the same level. We have a lot of know-how and data gained from that project, and we are ready to get to the next step, and we are actively looking for partners coming from H2 storage, coming from aircraft integration, from prototypical installation. Yeah, it would be great to have a partner in China to make the next project step.
Okay. Thank you, Christian, and thank you for getting up in the middle of the night for us. And
it was a pleasure.
Yeah, it's really interesting, and especially as when you talked to me first time about this motor, it was said, okay, it's just a proof of concept. So I'm really happy to hear that you're going further, and so thank you very much. And with this, we turning over to our next session, to the session like the schedule we had, which is development and application of AI and software in aviation. Because we think this is one of the key features of getting LAE taking off. And the first speaker I have here, I have Dr. Li Shipeng, who is the head of the Laser Institute at the IDEA Institute, and he's going to tell us a little bit about creating this
new ATC for the new LAE. Lee, stage is yours.
Thank you, Willi. Good afternoon. I'm used to today is like 15 minutes. I'm clock here. Talk a little bit about the evolution of the lower airspace management system. Because the slides is prepared in Chinese, so I will starting speak in Chinese. I hope the simultaneous translation will do the other part of translation. So my topic,
the topic of my speech is about evolution of smart lower airspace. It's mainly about methodology. I will not elaborate on technology. In the past, I have done a lot. It is my third year in a row participating in e-flight-Forum. Each year, I hope to bring some new content or aspiration to start with the thinking network. Last year's security system. This year is mainly about methodology. LAE has been developing quite fast in China. It is one latest news report from the China's official medium. By the end of this year, the market scale for LAE will be 1.5 trillion yuan. In the future, the market scale can only be larger. But there is a question is that people may just follow suit in terms of investment. We heard a lot from Mr. Tian about such a phenomenon. So from the national perspective, in recent times, there is the new instruction, which is that developing the new quality productive forces based on local reality. So for LAE, we also need to develop based on local reality. We cannot make it as a hype and to have the just all jump on the wagon and to follow suit in investment, because LAE is an important domain. We need to think carefully before making the investment. Mr. Tian mentioned about the new quality productive forces and about its relationship with the new productive relationship. So the question for my PowerPoint is that how can we cooperate the LAE with the local reality? For LAE, its development depends on multiple factors, for instance, technology and management. Finally, there is a spiral going up to the LAE at the top of the layer. On the one hand, we need to do the research and to have the strongest technology. On the other hand, it's about the most suitable. May not be the best, but the most suitable one. So the suitability or the compatibility, that is one important concept for developing LAE. So for LAE, the main parameters is that the total flight volume in one city. That is one objective target. If there is only a few around 1,000 flights per day, it's still in the nascent stage. We may have the self-disciplined flight by the aircrafts. The regulators approve the rules and operators use the rules. But the operators need to take full responsibility. So it is a preliminary management system like L1, just like autonomous driving from L1 to L5. In the second stage, like the 10 times growth, namely the verification period, because with more flights in the sky, we need to be able to see all the aircrafts to find out whether there are potential conflicts. If so, we need to give the warning to the operators. That is about the monitoring flight. For L2, management system. For L3, one level higher. That is the stage for Shenzhen right now. In Shenzhen, the daily flight volume is some 10,000. Therefore, we need to do the so-called guidance flight, not only warning, but also we need to tell the operators which feasible routes you can take to avoid the risk. That is about the guidance flight. The level 4, namely 1 million flights per day or 100,000 to 1 million, that is about a regulated flight. The system not only need to see the aircrafts to find out potential conflicts, and also the aircrafts need to follow the regulated pathway or routes. With high density, if companies do by their own, and they are easily get into the collision, danger of collision, going above 1 million flights per day, just like the ground traffic. That is the final stage, L5. But we need to do a lot to actually realize L5. Just like the cars, we need to plan the route. But for the individual collision accidents, that is on the drivers themselves, the management is mainly about the macro regulation, about the traffic control. So L1 to L5, development stages for LAE. Different localities may have unbalanced development. In Shenzhen, we have the largest number of flights. One day, there can be the combination of the flight number in one province. Some 3 years ago, we started this part of work, namely how to manage the system. We use the digital means to control and manage the physical domain, the space domain. Based on the digital twin control system, we need to manage the system, but also evolve with time. The system is not fixed. So we don't need to give up the system when the magnitude is higher or to make some constant amendment. The system can just evolve by itself. Therefore, in the past 4 years, we did a survey in different localities. We summarized the information in the chart. There are several dimensions. To start with objective ones, namely the scale and development stages and management models. The 3 parts are kind of certain, but in terms of technology, there is an interaction methods. And when the flight number is not high, we can use a manual control, but then we need to do automatic control, and also about the smart level, for instance, the large language model and also the algorithm. Granularity is about the distance between the aircrafts based on the drone management regulation. The current granularity is 1 kilometer, but that is not so realistic. We need to be more granular in the future. And also, we need to consider about the capacity matrix. So for different stages of development for LAE, the coverage is different. For instance, one community, one street, one district, municipality or province, we need to transit step by step. We need to ensure all the systems can be connected from the lower level to higher level. That is about systemic thinking. So by the information-oriented system, we can find the solution based on local reality to have the incremental growth. Namely, we make progress based on the past experience and foundation instead of build something from scratch. We need to have the future-proof ability. It means that the system can iterate based on the changes. 3 years ago, I mentioned about the 4 networks in this meeting. That was proposed by NDRC, joined with several ministries and promoted to the whole nation. Today, we talked about the low-altitude intelligent network, but now the definition is not so precise enough, so we make more detailed analysis. There is a SALAS system, the networks related with the digital system. That is all our system or structure. The core is about data drive. Advantage is that we can change the rules, but the dependency between data is unchanged. It means that from the beginning to the future, there is a room for involvement. What's more, in terms of the development, and we make it open and involvable system in each stage. Based on the previous stage, we can do some work, and we can allow for the different ecosystem partners to insert or embed their modules. It's more like the embeddable system. We can just have it is exchangeable, scalable, and replaceable. Last year, we proposed the Open SALAS 1.0. It means that we make the airspace visible. When there is conflict and collision, we can do the warning. It's more like the observer without giving recommendation. Today, within the chart, we can see clearly its capacity. 2 days ago, we issued 2.0 system further expand its capabilities. For instance, for all the modules, the adaptability and grading, upgrading, and capacity expansion. We want to give you some example. The first one is about computing framework, which is based on the 4-dimensional continuous space field. We didn't use the network or grid. The network has some cons or some disadvantages. If it's granular, high density, the computational magnitude will be much higher. So we use a new structure for calculation. We can greatly boost the computation, the calculation efficiency to make it more quickly to respond and to save resources in the system to have the second level response. Here I want to show you from the evolution process for the future-proof rules, and we can build it into the large language model. Then we just package all the rules into the so-called risk assessment module. Then we can do the evaluation on the module. And for this module, and we can be embedded into the route planning intelligence for any users, giving us a starting point and destination based on the rules and of safety. We can give you the route planning. What's more, we can convert the capabilities into different kinds of product metrics. That is important when we save it in different countries or different places. For all these different elements, we can build them into the matrix so that it is more suitable for local conditions. So there are 2 product series. One is the whole process management for low altitude. Second is about the whole process service. There are 2 series of products for each step, and we have the relevant different levels of products as the correspondence. Another thing is that because there are more flights, and we can find all the issues, and one problem we encountered in Shenzhen many times is that the helicopter encounter the drones. The core reasons, because they are 2 different systems, and also the heights are different. For manned drive, we use the pressurized height, and the drones use the satellite height. For the pressurized, the height can be different in different seasons. That is not the issue in the very high height of flight, but for the low height, low altitude flying, that is a problem. So we have the so-called the height box that can be distributed in one region to give us a benchmark about the latitude, so that we can benchmark. And for the pressurized latitude and satellite latitude, there is no definition differences, can convert them to each other. Now we are doing the so-called the mark with the CAC to build the latitude system. Another thing is some localities want to build up the system, for instance, a district what is the relationship with the city level system. We can gradually build up. Maybe we start from the district. Then we just connect all the systems in different districts and become the urban or the municipal level system. As for the solution we just announced 2 days ago with the uCloud, and we jointly built the integrated machine and open sellers integrator. So for community, for the district, there can be such integrator. Even the schools can use this system. So to summarize, the low-altitude economy is based on, it is not done all of a sudden. So based on local reality, we need to move gradually and progressive development. Finally, an advertisement for ourselves, and we just published a book which is called The Era of LAE. If you are interested, I have a sample here. You can just look through it to find out something you're interested in. That is about experience in the past 4 years for us, and really some meaningful stuff in the book. So welcome you to read it. That's my report. Thank you.
Thank you,
Mr. Li. Mr. Li has been the third time comer for this forum. So each time you bring to us something new about the low altitude intelligence and air control system, you provide us with really good framework and guiding opinions. The next speaker is the AMAP Navigation Gaode Yuntu Traffic and General Manager of the PAM government, Mr. Li Xinhui. He will share with us on the spatial intelligence, AI and low altitude. Let's welcome.
I'm very happy to have this opportunity to share my thoughts with you. Well, it's quite a professional forum covering manufacturing to energy to power drive to supporting facilities and etc. I was here this morning during the whole session. Well, I'm sure you have heard of Gaode. You use Gaode for navigation. And you can divide Gaode into visible Gaode and invisible Gaode. Visible Gaode is mainly, but by that I mainly refer to navigation, shared taxi, and you could also use Gaode to book hotels, buy tickets. It's basically B2C scenarios. And invisible, we also have invisible Gaode. Gaode has so many users, and so far our active user per month is 930 million, and 260 million active users per day. That's the peak figure, and Gaode is also enhancing itself continuously. We hope we could enhance the space into a smarter space, and all of those are based on LLM, large language models. Large language models are like a versatile scholar. He has lots of knowledge, he has wild imaginations, but these days we want to present the world in a visible way. That's why we want to use LWM. We want to use AI to reflect the real world. We want to have a simulated real world and control the virtual world using AI and digital technologies. And based on that, based on the smart space and our data, we have developed our capabilities in two ends. One is B2C, the other is the invisible Gaode. As you can see, we have the Gaode traffic table. You can identify those popular small stores based on the traffic data, based on the navigation data. On the other end, as I mentioned, the invisible Gaode, we provide those temporal and spatial support. We cater to low altitude and digital culture and tourism scenarios. We have also established an internet platform to support the fast development of this industry. And we could divide the spatial intelligence phase into 3 stages. The first phase is since the launch of Yunrui and Yuanjing, we want to use AI to showcase the real world. And the second is the age of openness. Other than Gaode map, we also serve nearly 400,000 apps providing spatial support. Through those apps, and based on Gaode's technology, you can see what's surrounding around a certain spot. So in the second stage, we provide access, or we provide open capabilities to different sectors of the society. And the third stage is the stage of symbiosis. They could, so as to promote a thriving and symbiotic industrial ecosystem and allow faster iteration. So based on that data, spatial data, temporal data, and our technologies and etc., we could have a big data foundation to support the running of a city. Also, we have 2 core products. One is called Gaode Yuanjing, the other is called Gaode Yunrui. Yuanjing, based on our latest technology, the 3D technology. In the past, when we want to get the 3D data, you need to have drones collecting data, flying around the city. That's quite costly and it's not that efficient. But this time we use pictures taken from different angles and then use AI technology to help us form the 3D environment and form that 3D data, and is thousands of times more efficient. And I'll show you later on the results of that AI generated one-to-one virtual world. So it's not just a static restoration, but it could also showcase the physical features of the real world. It could showcase the traffic of people, the traffic of vehicles, showcasing the real-time feature of the real world. And the Yunrui allow you to have a dynamic understanding of that real world. Based on that, we could serve all sectors of life, including low-altitude economy, 3D transportation system, smart business, and cultural tourism, smart cultural tourism. On the left, you can see Shenzhen Ronggang. We use Yuanjing technology to scan this area and restore the features of this physical world. As you can see, there's some awkward-shaped buildings. We have those glass-surfaced, glass facade buildings, and all of those roads, trees, buildings would be recovered in the virtual world on a one-to-one basis. Also, in some areas, for instance, in Beijing, the central area within the Zone 6 are all restricted for drones. So you wouldn't be able to collect data using the traditional way, but this new method allows you to collect data and recover the real world in a much efficient manner, and allow you to have high resolution, highly detailed restoration. All of those models are automatically generated, so it's quite efficient and it does not rely on labor power. The technology has also been iterating quite fast. We spent about 3 years studying this technology. In 2023, we launched Yuanjing, and all of those technologies are based on in-house research capabilities, and also we used large servers to generate those virtual worlds for cities. And after 1 year of iteration in 2024, we iterated this product again. So we first introduced in 2024. So in 2025, we upgraded our AI models. In the southern parts of China, we have lots of those buildings where the ground floor is actually a community area, and it's difficult for drones to or for AI to understand the structure of the building. And now we use the word model instead of LLM, and we could better interpret those glass facaded buildings. For instance, previously we could never imagine was on the other side of the moon, but now with new technologies, we know what it looks like on the other side of the moon, and that's a similar logic here. And also we converted the 2D map to a 3D map. And now, with the development of technology, we can have a 4D map, 3D plus temporal dimension. So that could showcase the change of the cities. For us, focusing on low altitude, the most important thing is the physical items, especially those vertical ones. We don't want our drones to crash with any of those tall buildings. But with this 4D model, we could know what obstacles there are, for instance, cranes and etc. For instance, this crane may be on the 28th floor this week and maybe on the 18th floor next week. And with the 4D map, we could update these data, these figures in a real time so as to allow highly dense drone flying in the same airspace. The low altitude development right now is carried out in a segregated area, and Hefei has already used drones to deliver cargoes for over 100 kilometers journey. So in the future, we need to we can use AI to help us achieve a whole zone or whole area visualization and efficient commuting. This is in Ronggang, in Shenzhen, in Dayun cluster. There's a bit image torsion here, but here you can see how these data are collected, and you can see the darker the color, the more populated it is. Low altitude development would also be impacted by the ground development, and the weather data, microclimate data can also be incorporated in this 4D model. And 100-meter or even 10-meter grid data also need to be embedded and linked. We can see that Beidou Fuxi are also working on this. So those technology and technological things, they all need to be engineered and incorporated into the system so as to create a 3D or 4D efficient spatial temporal model, and to represent the relationship between people, cargo, and aircraft. This is the second product, Gaode Yunrui. It includes a live map and a space big model. After 20 years of development, we have developed this live map. We could ensure high efficient quality data, and also we continue to iterate the coefficient to collect data and to pull data into one place. Well, in your navigator, when you look at your map, you can see different colors, red, green, and yellow. But now when you look at your navigator, you can see lots of other things. For instance, the traffic light, how long it would take before you can pass this crossing, and also conjunction alert and etc. Low altitude follows the same logic. From ground to the sky is much more complicated than the ground environment. It has lots of elements, including electronic magnetic information and etc. as well. All those route planning and etc. all require these data input. So we need to have multi-dimensional data calculation, and that calls for Yuanrui, which is based on the live map and the space-big model. So sometimes people would call this 空中 or airborne 高德. So we allow airborne calculation as well as airborne operation. Low altitude economy is not just about the management of low altitude elements or aircrafts. It eventually needs to be an economy. And so we need to serve those elements in that economy. So on one side, we hope governments and enterprises can have stronger operation capabilities. On the other side, we hope we could better serve our customers and create more consumption scenarios, so that eventually the LAE can have a closed-loop development. So infrastructure is crucial for LAE, including takeoff and landing paths, weather data, and etc. And we hope we could digitalize everything and put them into one platform so that those suppliers and the service providers can quickly iterate.
At the same time, we can have the airborne matchmaking about the demand and needs so that we can build up the closed loop in commercial application. So for the low altitude economy, a product is like the aggregator, just like the Gaude packs, the cab hailing. It is like the top commuting and traveling platform, but we don't have our own transportation capacity. Instead, we do the matchmaking so that there is a balance and dynamic adjustment on the two sides and to improve the safety and the efficiency of transportation. So does low altitude by providing our capability, and so that more manufacturers they participate in a low altitude. At the same time, more users can enjoy the benefits and convenience of low altitude. We talked about capabilities, but now we need to have the scenarios and including the OneNet, the government of one-stop flight. And there are some logistics scenarios, and I think that is about in Gaude, we have the flash delivery to integrate a series of logistics platforms, and for the matchmaking, there is a low altitude cultural tourism. So for Gaude, apart from aggregator, we need to integrate the downstream and upstream of industrial chain to ensure the fast iteration and development. The final part is about the low altitude industries, and we have the industrial funds and to accelerate implementation. At the same time, but the tech empowerment in training to connect the dots in the industrial chain so we can ensure the implementation of the low altitude plan in the marketplace. Thank you.
And again, we are going to change, sorry for my delay, and again, we're going to change the continents, we're going to change the countries, but still have the same topic, having AI in new aviation, having AI in low altitude aviation, and having AI maybe also in the aircraft itself. And our next speaker, Marco Hirsch from the company Alpha Frog, he tells you a bit about what he's working on for getting the new LAE, all the aviation in there more efficient. Marco? Stage is yours.
Yes, hello. It's a pleasure to be here for the second time. And demonstrate a little bit about our last achievements during the last year. So the idea is to make a new instrument system, or avionics, we could say, for the LSA Mosaic upcoming aircraft. So we want to have that in an economical level that we have not reached before. So where do we come from? I founded the company Accentra in Germany over 20 years ago. We've been providing product data management systems, product lifecycle management, and we generate virtual products and digital twins for over 20 years for companies like John Deere, BMW, Mercedes, and Audi. And that gave us insights in processing large amounts of data and also processing and analyzing the data. The Accentra Holding has 3 companies. One is the spin-off. We spun off in 2023. It develops a platform. It's called a digital thread platform, thread with D at the end. So it's about generating digital twins in an automated way of your production, of your product, of your logistics, of your organization. So with that, we have superior knowledge graphs and automate these AI-driven digital twins in any ways. And we are having my side project, you would say. It's a smaller company, Alpha Frog, only a couple of employees. And we did the EG1, an electric one-seater, and a concept called EG4, a 4-seater that fits in the Mosaic Mosaic range. We did this with a company Casero that is also present. Carl Kaiser supported us during that phase, and that's already a couple of years ago that we did this. And we all had hopes for Mosaic coming fast, but we know it's always taking longer than we think. But it's on a good way, and we're very much eager to see it. It left us a little bit more time ourselves, so that's cool. And we're looking for joint ventures here in China, especially in the area of the avionics software and strategic partners that we could work with. All right, the mother company, or one of our subsidiaries, the EXP, was present at the Hannover Messe Industrial this year, and we received the Factory Innovation Award for showcasing Omniverse, a metaverse where we showed the whole battery assembly plant that was AI-driven, and you could demonstrate how the AI is signaling you about occurrences inside the factory, and the AI is also knowing about any data event streams that are running in the factory. We also received the NVIDIA Innovation Award for this, and ever since we are partnering with NVIDIA. So Mr. Gu yesterday said that he flew a Cessna 172 that was retrofitted with a Garmin G1000, and he still didn't like it because it was still consuming F-gas and was probably loud. And it's just the old planes that we update. We pay 6-digit numbers for that. And the question is this still the way to go? If we look outside and we enter one of the auto-flight systems, we see definitely a change in the avionics system. And I guess we all know the path is a different one. So fly-by-wire is just one thing, but having sensors, rich sensoring, having flight assistance will be the standard soon. If the VTOL evolution would not be here, we would probably fly our old systems for the next six decades or so. But in a way, luckily, this is happening, and this is kind of a waking up the old traditional way. So out of the urge to prove that this is also possible in the conventional planes and in small aircrafts, we bought a 40-year-old project called the Scirocco. It was the first ultralight aircraft that surrounded the world, and we updated it to a digital motorbike of the air. So we made everything new, basically. We could just probably kept a few screws, but besides that, it's all new. And it's electrified. It has a redundant battery system, redundant controllers, redundant engine. So everything is redundant to a high degree. And we put in this synthetic vision, which is based on a standard tablet computer. It's just a tablet that we active cool because it has high resolution, it's lightweight, it's proven. And we have a backup system in this, it's the Garmin G5 system, and also a board computer system below it. It has a COM radio transponder, so it's participating directly in the standard airspace and is having all you need to fly. But what's then the purpose of that? I mean, others are doing this already, so that's not really very innovative. We have a synthetic vision inside, which is able to be used by a 5-year-old. So we demonstrated this at the Aero, and it was fantastic how the people were instantly moving the map and were knowing what to do. So it's really not necessary to go all the way. I mean, there are things we need to do because they're for trained pilots. But the things we can do easier, we do easier. Of course, it has collision detection, and it has a Starlink that's built inside the wing for a satellite connection, so it's always on. It has a fallback with 5G. It can do over-the-air updates, of course. It has emergency features, so you will be glide assisted in the case of an emergency. The red button, you just press that, and then you get advisory and assistance. It also has a high-precision wind measuring, which allows us to predict where turbulences are, what our time of arrival would be, our range. Everything is influenced by that. And we have a LiDAR system that is a long-range LiDAR. Well, you can argue what is long range, but 450 meters, quite good for a LiDAR system. And we have an angle of attack measurement. But this is still not the whole thing. We combine this architecture or this new avionics in a system where it's always on. So we have a backend, a cloud backend, where we stay connected with. So you can download a smartphone app and monitor when your friend is coming and how he's doing, and many other functions I will come to briefly. So this is the display of the iPad app. In the sky, you see an airspace that you should not be in conflict with. And on the left-hand side, you see a measured thermal probability. So you will most likely be in thermals on the left-hand side. That's good for gliding and maybe sometimes to avoid. You can enter the frequencies and you see like you're on a roller coaster where you have been flown. The app is able to support you in booking your aircraft with others in the hangar. It controls also your flights, your flight log. It will also give you updates of the charge of your battery, or if you have combustion, your fuel tank. And it's easy to monitor and to communicate and to collaborate with your colleagues. It will be a free download, so it can be used by any pilot, and we want to motivate the people to use this software. We showcased this in Blois. That's the largest European ultralight event last year in September. And this year at the Aero in Friedrichshafen, we also have shown the product with the new full canopy that we offer. and ready-to-mate sensoring. And on 7th of August, finally, we did our flight, our first flight, maiden flight, and was a charm. It was working as intended with only some minor changes. Okay, safety is a big thing. So software can help us to reduce accidents. So we had in 2021, 1,154 accidents in the general aviation with 565 fatalities or seriously injured people. That's 2.5 heart or fatal and serious accidents per 100,000 flight hours. We believe that it is possible to reduce this number by 2/3 if we have assisted flight. So why that? So putting in a new system, that's also kind of a new era for us. NVIDIA brought out the Blackwell 2.0 architecture. You might have heard of that already. It comes in many robotic systems, like the humanoids. It's kind of the future of robots. And at the end, an aircraft can be a robot. And you put in the same heart of a robot now in an aircraft. And it must not be a big one. And it has a computing power which is tremendous. So this little thing has 128 gigabyte of GPU RAM. GPU RAM is the one that is used by the AI chips, which are specially made, leveraging this GPU memory. By that, you can install all kinds of artificial intelligence modules and models. And it has a special capability for sensoring, for video processing. And so this becomes a robot, basically. So you have a hardware abstraction layer with an inertial measurement unit. You can put on the actuators, cameras, and then in slower frequencies, the higher you get on these layers, you have all kinds of functionality that you're enabling. So you have natural language interaction if you want, so you can speak to the system, and the system could also, just one application, manage your communication, help you to communicate if you, in cases you misunderstand something, or if you want to answer to a direction. So it's a complex architecture. I will not go in depth with this, but it's a really powerful one. So as I mentioned, you can host many models on that, and you can train these models as well. So you have a foundational model, and on top of that foundational model for the purpose of controlling the aircraft in terms of interpreting your situational awareness and also your planning and your strategies. You can update the model with your own models. So we have a training then that is running inside the aircraft to update this, but it's also running inside our digital twin environment called the Omniverse. In the Omniverse, you can train the aircraft situations before they come. So upfront, you're training them, and you're training them in vast amounts. So you can try to avoid collisions. You can try to auto-land an aircraft in difficult situations in between the mountains while their turbulences occur. So all this is possible to be trained in a virtual environment. And the training data is then represented in the model, and the model is then active inside your cockpit. So last year I already showed that we have several sensors, like 8K dual lens and the LiDAR system I talked about, 5G and Starlink for communication, and temp sensing and stuff like that. So basically not really so much fancy stuff. You don't need that. We do have intelligent algorithms and sensor fusion that allows us to be very precise regarding the wind measurement, better than the weather-based stations on the ground. So that's quite cool. So that is allowing us to really feed the AI with all the necessary information. So just quickly, the AI is running by seeing the physical world on top with the sensors. And our AlphaFrog flight system is automatically collecting the data in, perceiving the data. This is giving you the self-awareness, your localization and positioning. And then it will determine what kind of objects it needs to pay attention to. So that could be ground, that could be obstacles, that could be maybe the weather model that gives you back turbulences. And then it will respect all this in a situational awareness and predict the best possible flight path for you. And act by giving you the ability to let it steer for you. But we all know this is not possible now, so we keep on human in the loop and pilot assistance. So in summary, AlphaFrog partners with NVIDIA to deliver an AI-driven flight system as a platform. And we still need to keep the human in the loop factor. The whole system costs not really small money. For a drone, it would be too much, but $35,000 for all the sensoring, all the hardware, AI computing, the servo systems, that's the hardware cost. And that's for all the equipment, not bad. We're looking for partners that we can continue the growth and the capabilities of the platform. And we're also willing now to take the AFS and equip other aircrafts with this. Yes, and I'm happy to talk with you and see my WeChat ID here. And maybe you have interest also in implementing such a system in your own plane. Thank you for your attention.
Thank you very much, Mr. Marco Hirsch. So he talked about avionics. So eVTOL electronic flight, well, despite its small size, are quite different from traditional airplanes. Powertrain, avionics perhaps need to be heavily adjusted to suit the purposes of e-flight. The communications and the interactive manner may be completely different. It may be smarter. So that means higher requirement for artificial intelligence and technologies. With that, I'd like to invite our next speaker, Mr. Qian Shaochen. He is the boundary head of self-driving and navigation department, and he's going to talk about AI empowering the low-altitude economy, technological accumulation, and breakthroughs of boundary AI. Good afternoon, everyone. I'm Qian Shaochen. I'm from the boundary head. First, please allow me to introduce myself and my company. I got my BA from Zhejiang University and I did my MA in Germany. And then I majored in sensory and algorithm. And I joined this company since 2020, and I now focus on big model and the relevant algorithms. So Boundary AI is established in 2020. And in the last 5 years, we have been working with quite a few eVTOL companies, forming long-term strategic partnerships. So far, we have about 100 people in our team. We also have many of those are experienced veterans with domestic and international background or experience. Right now, we are working on VE25, the 6-seater, and the GoVR06. Also, the second layer are still in the prototype phase. We are also working with COMAC on a 19-seater electronic plane. So back to the theme of today. Well, autopilot system now is widely applied, relieving the pilot, and in some cases, in the automobile cases, we see autopilots sometimes replacing the driver, and we believe this area will see further development. Low altitude auto control system is not a replica of their auto counterpart. There are lots of differences. First of all, on the sensor level, well, aircrafts are much faster than cars, so the sensing distance should be much longer. And second, it's more difficult to collect data. In terms of planning and decision making, they need to make decisions in a 3D environment, but for cars, it's 2D or 2.5D. Also, cars, they mainly interact with people, bikes, and other vehicles. It's more a social prong decision. But for aircrafts, as real time, it requires much more redundancy and requires high robustness. The dynamic system of aircrafts are also much more difficult than automobiles. So it requires much more robust control. So facing these challenges, we are now working on these following 4 aspects. We hope we could provide or establish a closed loop covering these 4 stages: control, navigation, sensing, and decision making. And I'll mainly talk about the sensing part. This is the sensing scope requirements of D0387 photoelectro detection sensor, minus positive 100 and 15 degrees. And different layers of sensing distance requirement based on the size of the target and the direction of the target. As you can see, this is about 3 nautical miles, about 5 kilometers in one direction. That's pretty long distance. So one key challenge is small target detection. This is the width and height of the 2D target. As you can see, most of the targets, they concentrate on the left corner. That's all extremely small items. And on the right, you can see a tiny kite in front of you. So given that, we have optimized our detection algorithm. We used a highly resolution feature image, labeling technology, and loss function. Low altitude sensing. Regarding low altitude sensing, it's also much more difficult to collect data. On the ground, you can perhaps mobilize a fleet on a relatively low cost basis, but it's quite expensive when you want to do the same thing in the sky. We have a fleet of UAV helping us to collect data. We also have data collector mounted on top of those UAVs. Also, we used models to generate models of aircrafts and then import those models, those data into Unreal to generate data. Also, we synthesize data. We use rendering to generate synthesis data. This is a synthesized picture. You can see this is in Shanghai along the Huangpu River, and you could see a dense crowd of aircrafts. And this is not the reality now, but this is something that we may face someday, the future challenge of low altitude economy. So once we get those data, we need to convert those data into products. We have a semi-automatic data conversion line. First of all, we'll have a pre-detection model to detect the potential targets in the pictures and then put those results to a big model to screen those data. And the results of both processes would then be sent to humans, and human would correct those errors, make further labels, and then feed back to the models to do a second round of reviewing. We also have lots of deployment experience. We can use PyTorch to do training and then convert it to ONNX intermediary and then put it to RKNN or TensorRT, those logical models. To ensure the reliability of those AI models, we strictly follow the W model proposed by EASA in 2021. So first of all, we'll define the needs, and then we would collect and produce the data sets compliant with the needs, and then divide them into 3 subsets. Then we would have a learning process management, design the model, optimize algorithm, prepare the parameters, and etc. And then we would use the training subset and the iteration subset to iterate our models until the model is good enough. Then we'll use a brand new data set to test the model.
After that, in the future, in the model operation platform, we need to realize the model to do the self-verification. Then we'll have the third-party independent team to do the verification on the database and also to verify the above process. So based on the above-mentioned work and development systems, we mainly focus on the 3 production lines. The first one is about VIO, visual positioning. The second one is about sensing, obstacle avoidance. For the DAA, detect and avoid, there are 2 parts. The first part is about the source of monitor. The second part is about computer. The source of monitor is about acquiring the information for the aircraft. There are 2 parts. One is a coordinator. The coordinator is able to transmit the information to outside the world about its own information. It usually has ADS-B and responder, etc. For the non-cooperative target, we need the aircraft to have the active monitoring and exploring. There can be some cameras and radars and lidars, active monitoring devices. For the information from the sources delivered to the DAA computer monitoring and tracking module, then the module for each aircraft there is independent tracking. Then the tracking information will be delivered to the threat resolution module. Under different structure, the DAA system can have different output. For manned aircraft, the DAA module can put the information of the invader and the suggested avoidance and rules to type it onto the display system to assist the pilots. For the simpler structure, unmanned aircraft, the DAA can output the flight control system so that the system will do the avoidance. For more complicated unmanned, the DAA can send the information to the flight management system to interact with the flight control system to avoid the collision risk. It is a video in Guangdong, the rural areas. There is a visual inspection. The system demonstrates one video. On the right side is the zooming in of the target, so we can support and tracking and monitor the UAV that is in a remote distance. Then is about intelligent landing, the production line. For the future aircraft in the process of landing, it needs to make a judgment whether the place under the aircraft is suitable for landing. In emergencies, there is a self-help landing process, finding the right spot. On the left side, it is the input information by the sensing system, some dynamic targets. On the right side is the understanding of environment for landing by the sensing system. The red part means suitable for landing, but for other colors, it means not suitable for landing. Based on visual positioning system, in the failure situation, it will provide the location information, for instance, the speed, location, and altitude, etc. Now, for the consumption IMU, it means that without the map, we can have the area lower than 3% of the total range. It is the more mature product, already hundreds of units delivery. In conclusion, we're accumulating some of the experience autonomous driving, autonomous flight. In the future, we hope to join with the colleagues in industry to accelerate, to embrace the new era of autonomous flight. Thank you. Thank you for your introduction and the work of your team. We need to thank AI in the application scenarios in the future. In so many aircrafts in one airspace, people's wisdom cannot follow up, cannot manage the system. Today we talk about AI. We need to consider another issue. That is about the AI and the human intelligence. What is the border and the segregation of responsibility is not only a technology issue, but an ethics issue or management topic. For CAAC and for such aircrafts, what will be the control border with AI, how to distinguish responsibility. Second part is about interaction. The target for interaction of AI may not be a professional, but a passenger. That is one key point. The final speech for today, the Shanghai Zhefei Aerospace Technologies President, Mr. Chen Kaiming. The topic is AI for engineering, the Zephyr's approach. Welcome, Mr. Chen.
抱歉啊，名字可能念的有点连错。需要这个吗？
有那个翻的笔页在上面吗？哎，在上面是吧？
好好好。
我好像每次都是最后一个。
It seems that I'm always the last one, but it's okay. I just made the PowerPoint last night because I thought a lot about how much to share and how to share it, because there is some frontier content. For AI for engineering, that is a hot topic nowadays. That Zephyr's approach is all based on our own experience. The company name is Zephyr. Introduction of us, and we were founded in 2022. We focus on core system, the flight control, energy, avionics, intelligent driving, and the engineering service. The most members of us used to come from the COMAC, the AVIC, CATL. That are the team members. In Shanghai, some more than 10 people. We are serving a lot of OEMs in the industry.
Okay. Right. 这个字体好像没有显示出来。Okay. Sim to design 仿真到设计。
Simulation to design, topic 1.
让我们先对付一个这个行业内最恶劣的问题，最 tough problem。
One tough problem in the industry.
可能有些英语在穿插里边。Okay, so let's tackle the toughest problem in flight controls, Autoland. 所以在适航，左边是所有这些适航的要求。
On the left side is all the requirement for airworthiness. On the right side, there are some description of the question. For flight control, it is a tough problem. For commercial aircraft, and it is usually done after the airworthiness certification. It is a field operation test. In the whole process, in the flight control system, in the auto flight system, there is all kinds of conditions without interference. We need to land the plane. Certification, it is heavily based on simulations. It is a statistics-based analysis. Monte Carlo simulations. The magnitude is 10,000 to 100,000 simulation cases. So we developed a system, it's called Zephyr's Super Real-Time Parallel Execution Director. Sounds like a quite unfriendly name. It is like deployment in multiple cores to have the more than 1,000 times real-time speeds. Within 5 minutes, we can run some 1,000 second case. And also the simulation management framework of the data and the post-data processing all in one box. It is the real customer data. The Autolight, that is a requirement. One important thing is that in this project, for many times we talk about the 10, the -7, the -9. In autoflight, the -7 or 8 or 9, quantitative can be like correspondent. So this is important. We need to aim at the target. We need to go into the very narrow, the width of the runway. The angle and for landing and overloading, we need to go into a very narrow space or narrow scope. The ultimate target is that by deep learning, for the large amount of quantitative simulation can be reflected into the control system. That is what we are doing now, and progress is being made. So basically, by quantitative or by the large amount of simulation, we can resolve this topic, resolve this problem. So number 2, what we are doing, AI for modeling. I mentioned about some excellent simulations. They are meaningless if we cannot do the modeling. Modeling is one neglected part in the industry. That is also one advantage of us. It is indeed time-consuming and people-consuming. The recognition of us is that the same is engineering. Everybody is doing MBRC, MBD, but seldomly can people do it really good. So simulation engineering, it is engineering our habit to develop the complete simulation model. It is impossible for us to invest in a lot. We have some CAE, CFD, or ANSYS data, or Fluent, etc. But for the data processing to build a model, that is a time-consuming Sometimes it's still intensive. It means we need to have a lot of requirement from the engineers team. What do we want to get from it? We hope that something can help us to build the model, feed the data in, and the full model out, and abuse compute, because computing now is so cheap. Much more cheaper than engineer. If I can abuse computing to save some headcounts, I will do that. So it's called Flow Expert Flex. The Flex, and it is the combination to ensure the precision and also the accuracy in physics. There is a deep learning and also the physical combination.
We're training neural nets to replace traditional lookup table, but form is fixed.
So the form is fixed. We're training neural nets to replace traditional lookup tables, but we use the neural network to do the job. Rapid prototype, we can do it repetitively. Build for post-model parameters, identification, we can develop a lot of things, but finally for certification, we need to do the simulation. So we can combine the simulation environment with the physical objects, for instance, and in the flight period, we need to do something intensive, parameter identification, the basic framework.
So basically, just 变成了一个 model-informed neural network.
So it is a model-informed neural network of MINN. We are going to write a paper with a professor on that. In our workflow, the build model, we put the data in, abuse compute, and get a model out, and the target.
Right. So, 我们把原来3个月的 alternative.
So for 3-month traditional workflow can be shortened to 3 days. We have hundreds of tables in a distributed environment.
So yeah, that's pretty good. 然后是我们不光是飞行力学。
Not only the flight dynamics, including the landing gears, battery models, actuation models, or server models, any dynamic simulation models, we can do that. We do also have the parameter identification module for the prototype. We have a lot of identifications of real data, so we can just return the data to the model using deep learning. Humanoid robotics. One major issue for ISAC-SAME, everybody is training the model in the ISAC-SAME, but we find that the data is not right because it is not possible to inject authentic, calibrated data in the. We cannot calibrate the data.
So we will work with a robotic company later on with this model to provide this modular to them so that they could fit a good parameter set in the real world and then back to ISAC-SAME. This will greatly enhance the model. ISAC-SAME is quite popular. People believe that you don't need any modification after that, but actually that's not true. We have 2 modules. One is Flex, the other is BAT, one for simulation. And we will do beta testing in 2026 Q1 and release in Q2. Our early customers would be big players in Shanghai, and we offer free trial for all of core customers. So this is good. It's quite quite brilliant to use back to auto landing, autonomy. Previously, auto land would require localizer, localized slope signal, or GPS or GNOS. This is what we did in simulation. It's a bit different to boundary control because we have a common framework within this loop.
这是我们的 runway。Remind you， 这个不是事先标定的数据，这是
This is not pre-labeled data.
没有 GPS， 只能靠距离和
This is purely based on position and distance as landing based on estimation. This is something that probably most difficult in flight control. On the right, you could see the simulation base, detect and avoid. We are heavily relied on simulation. Simulation in early stage are quite helpful. This is different weather conditions against the light, for the light, and etc. This is autonomy framework. This is our common architecture, whether it's detect and avoid or auto land. We have a rather specific common sensing network. In the middle, we have Atlas, a framework. It relies on domain-specific language. It can be extended to a wide framework. And we also have a direct end-to-end feed-forward. On the left is the future product. On the right is the existing product. So here we have a bidirectional unified ontological framework for training data generation and autonomous action. So the training data is going backward, but autonomous action is going forward. So we'll do the same thing twice to solve this issue. It's very elegant. Number 4, we have only 3 minutes left. So AI development process. We have a rather complete tool chain. We have a DO311, DO178, and ARP4754. It's very rare to have the letter 2 in the same framework. Why do we want to put these in this framework? Well, when setting up this tool, we realized that we are very short of labor. We don't want to draft the documents. We don't want to do those manual work, those non-standardized repetitive work. So that's why we built this framework. We'll have an AI tool to help us to do those painful things. We haven't decided whether we want to use LLM or another technology. And this tool will help our engineers to do these things. As you can see, it's auto-running. So it's quite interesting. Language interact, it would remind you what you need, problem tracking. We have development innovation tool, tools for engineering and autonomy. That's for the future, and we hope we could showcase these technologies to you gradually. Thank you, and see you next year.
Thank you very much. Please stay up stage because we have our last panel for today. And the chairs are coming up. And please, the other speakers, Dr. Li, take my paper so I don't forget. Marco, is it there? Okay. So, yeah, okay. So, unluckily, Marco can Li, if you could come up. Who else we had in the session? Yeah, Marco, I just heard he's in the parallel session, so he's unlucky that he cannot join us here. Who's missing? Have a seat. Who's missing? It's okay. It's enough. We don't need more. Gao? There is, I think, one Chinese speaker, Li Xipeng. Chen? Okay. Li Xipeng, CD. And Qin Tian or Chen? This is Tian, yeah, okay. Chen is here, Li is here, and Li Xinghui. The second speaker. It's also on the other side. Yeah, so that's the thing. We have a problem with the panel, but we have now unlimited time, as it's the last session. Unlimited time. Okay, so reading glasses off. Yeah. So the challenge of AI, as you're working in AI, and when you work in AI in aviation, a lot of people are kind of afraid of AI, especially in the Western world, where they say, okay, we don't know. Maybe later the computers will take over and control, and I lose control. So maybe each of you can shortly say what he says to somebody who says, oh, you work with AI in aviation, isn't this dangerous? So what would be your response on this? Maybe Lee? Okay.
I think this is a very interesting question. We talked a little bit the other day. So there is, I think AI is a great tool to reduce the time for development, even for the real system. You can assist you to make the decision in the end. But you are dealing with a physical world. So everything or every conclusion you made should fit the physical law. That's my take. So whatever AI is doing, in the end you land with some real physics. So as long as you can combine the two aspects together, I think you will make a good product. That's my take.
Oh, dude. Okay, so I have a 14-year-old, and it reminds me of how to deal with a 14-year-old boy, because you cannot control something that is eventually going to be smarter than you without having bad consequences. You got to be very carefully approaching it. Okay, number one. Number two, fear is. I think in the West, if you fear something, generally speaking, if you fear something, you're gonna have bad results, because that means you don't want to face it, you don't want to deal with it properly. It will cloud your judgment. Fear is a bad word. What you need to do is very carefully to go and analyze the problem and say, what is my relationship with this technology, right? And properly develop a framework for it. I'm not saying which framework is good or bad. I don't, blindly march forward as a framework or tightly control the framework or whatnot. But eventually, we have to deal with it. So fear is out of the window. You cannot fear this thing. Number two, it's very, very useful. In our case, it is very, very useful. And it's integrated into our processes, right? We're a software-heavy company. If we don't do this, we're stupid. We're stupid. So will be malpractice. But it happens that so we don't have fear, right? But what we do is we'll do very careful human the loop to say that if we're missing something, right? Or our most fear is out of the control, right? So human the loop, it's doable. Yeah. Okay.
Okay. So Ken, maybe same question.
Yeah. I think from my perspective, this is a very, very huge question. And I think from the technology itself, the explainable or interpretable AI is then cutting edge technology. A lot of researchers or big companies, they are on it. And I believe in the future, the deep learning model, a neural network may turn from a black box to a gray box or even to a white box. I think that's the way. And from the engineering side, I think as an architecture, that we can decide in which modules that we may use AI technology, deep learning technologies, like in system critical modules like flight controller, or the modules that was very high design assurance level. We can avoid the use of AI, at least at this stage. Yeah.
Yeah, I think that's probably also what is required by the certification bodies. Like, if I look at EASA's white paper on AI, it's exactly closing this out. So, what do you think? What will be the first product in the aircraft which will be airborne, where you will have some AI? I know AI is a very way, you can everybody calls everything AI. Every cell phone says now with AI technology. But what would you see as you're working in this? Where you think you will see first AI components in maybe data generation use? Instruments, the control system of the aircraft, or maybe systems like Autoland, or getting one step higher, a whole air traffic control system. So maybe you start, Jan, as first, and we go backward, because these are all questions which I think go to all of you. And again, although our audience has shrinked a bit, if somebody has a question, you're welcome to come up to the right side and ask the question.
下面有问题的哈，那儿可以提问。
Feel free to ask questions. I want to ask Mr. Chen. You just showcased us auto landing and auto crashing avoidance. You use AI to do calculation. So, in terms of operation rules, what's your thoughts behind that, and how is it done?
Chen will answer your original question, I think. Okay, so 我回答一下，非常简单，就是。
So to address your question, it's quite straightforward. So you can see our Stella framework in the last page of my presentation. It may not be that detailed and clear because we are short of time. We have a environment called Luyi. In that environment, we have a framework defining all the policies. We have some domain-specific languages embedded in the framework. There's lots of jargons in autopilot area, domain-specific language, plus autological dictionary, contextual dictionary. And based on that framework, we could convert the CAAC rules into computer languages.
So, okay, based on this the basis still have the value for capacity. The capacity is a limit for sensors and computers. No limit. In my initial testing, it's like the tens of thousands of synthetic fusions. The constraints factor is like tens of thousands. What I'm trying to say is a target capacity. For the capacity of the cooperative and non-cooperative targets, do you have the plan? As we think it, thousands will be okay. Because the computing size very efficient. 1 second to 0.1 second, we can run the loop. Refresh rate is high. So in the future, the hundreds, thousands of operation is based on your technology. We count on you. Thank you.
Okay, does the other two would like to add to the question? Yeah.
I want to make some addition about capacity. Currently in the D0387 for the detection system, the capacity limit, the minimum requirement is 10. It requires that the sensing perception system need to track 10 aircrafts in parallel. That is the minimal standard.
Okay. Then my question would be, when we're looking into this new world, and we have development of AI in Europe, in China, and in United States, and you have aircraft development in all these countries and even many more countries. Are you already working on standards? Because I can think if everybody's working on his AI definitions in a certain way, and we don't have concrete rules from the authorities yet, and they are also not agree on the standards, are you among the industry trying to work out standards? For example, if you have an instrument for the detection and you have an air traffic control system above it, there must be communication aircraft to aircraft, there must be communication aircraft to the system and to the ground and to other traffic. So I think it's again a question for all three of you, and you're working in different scopes of the microspace. So maybe again, Lee, you start and we go.
Yes, we definitely working on the standard aspect from the because we are building the infrastructure and the management system for city. So you have to make a lot of standards. So we established several standard activity group in China. With one major initiative is working with the CAC, trying to make the altitude standard, the commercial standard into a standard. That's sort of some other a big problem. We are also working with people outside China to see, what can be standard, so that in the end, and the world talking with same language. The nice thing about doing this, including AI stuff in China, is we have a lot of data. Like in Shenzhen, normally we'll fly 10,000 different drones in 24 hours. So we accumulate a lot of data. So we can use that data, probably with the help of AI, to find what's the best rules to make, what's the best standard to make. I think that's another aspect of using AI. Okay.
So here's my point, and I'll go back to EASA a little bit. And so I think EASA is grossly outdated in regards of this area. The certification framework for this doesn't work. It doesn't work, right? So it probably will hold back the industry. That's my personal view. On the nicer side, I say we need to update this, right? So that's number one. So certification-wise, it's grossly behind the automotive industry about one product cycle. And so number two is this. So standards. So last time I was watching that little video, and the size of the rocket diameter is the size of 2 horses' ass. Why? Because the Romans built the roads that way. So we don't build the roads first. We put together a wagon first. Right? Standards comes after the product. Always in the real world, it's actually like this. So I'm not saying you're wrong. I'm just saying that in the real industry, which is what I do for a living, our customer has specific needs that needs to be met. And we'll go very aggressive on that, regardless of if there's a standards, if there's no standards. If there's standards, great. We'll comment. We'll see if we can follow it. If it's not a forced standards, if it's a heavy regulatory standards, we'll try to our best to influence and whatnot to see something makes sense or doesn't make sense. But on the other hand, we're very conservative. We're very conservative in that our system, our autonomous system, we always try to build it like it's a co-pilot. It's a human pilot. I always go back to this, what would the pilot in this case would do? And if you look at our framework, a bit on the corner side, you'll say, there's actually a rule or agent. And that rule agent is basically the flight manual and performance tables for the aircraft. So what happened is we'll try to make our framework act like a very well-behaved, very efficient human pilot. Whether or not there's air traffic control rules outside, whether or not there's a low altitude air traffic control system in there, we treat it as like an input source. But internally, it has to behave exactly like a human. And it's good enough that way that right now we can actually push the product out to the industry. So we're very aggressive in push the product out, but our product is human, very close to a human pilot, right? So this is the...
Answer on the question. So maybe hear your answer, because I have a follow-up on this one, but maybe your opinion on the question I asked before,
like the certification or standards?
Standards, like you're working already together with other companies defining a standard, or, for example, trying to establish an ASTM committee to define a standard so that the anticipation which the pilot do is the same. Because just for explanation where the question is coming from, when you say, okay, behave like a pilot, like if you behave like a pilot, you fly into a swarm of 500 drones. You have no chance to control this all. But with an AI, you may have it to control and to get the information and to get the flight path right. So maybe you must be kind of super pilot if you want to fly in this future world. No. This was just an explanation for the question. Yeah. And then I will ask you this question afterwards. Sorry.
Okay, for standards, I think I've actually read a lot of papers from EASA or FAA, and basically there's a company called the Dedalian from Switzerland that they are in a very close relationship with EASA and the FAA, and they've write so many papers, and they are trying to establish this certified framework for AI,
the rule for everyone.
Rule for of course. And I think basically this is still hard. I mean, if you want to establish some standards, like you satisfy this, and then you can guarantee the performance of the AI system or neural network, I think this is cutting edge topics in research area and industry area. I think this is very hard actually I'm keeping my eye on this, but actually currently I don't see any organization or any group are really capable of solving this. Yeah.
I have a couple comments. So in the autonomous driving industry, there are people working furiously. There's a large group of people working very furiously to basically make the autonomous driving functionally safe. And we're actually working on this with a group from Europe, but it's actually not EASA and FAA. Again, my comment is they're about one product cycle behind what the cutting edge will doing. And what we try to do is actually get from the best. Airplane industry, aerospace industry is grossly outdated in this regard.
I just want to say, like,
grossly
at the engine,
we're not going to learn from the
engine
worst
manufacturers, and what is the standard engine in most of the aircraft
So standard comes after the product. Don't get the horse behind the car, right? So we're going to try to learn from the best industry to do this, but we're not going to say this is the standard, we're going to stick to it because sorry, this isn't going to work. Dedalian didn't certify their thing.
Yeah, maybe it's...
So that's why I'm putting my comment. So back to your question of swarm of drone pilot flying into consumer drones. So what would a human pilot do? Because you're going to have human pilots and non-AI and AI-assisted pilots dealing with the exact same situation. What would a pilot do in this situation? Now, either air traffic control has directed him to a very bad area where there are swarm of drones is usually in the delivery site, which is grossly screw up. Somebody really grossly screw up.
It will happen.
It will happen. And is it just AI's fault? No, it's air traffic control's fault, right? Or else can that save his life? Probably, right? He's going to have to detect, avoid, and save his life. So we're not saying, because AI will have to deal with 500 drone situation. it's going to fail and we're not going to, this is a terrible situation. No, just what would a competently trained human pilot will do, and will do better than that, at least as good.
You have to do better. I think you have to
At least as good and better, greater than equal to, right? So a lot of these situations where these products were built with in mind that we're going to have just like have a guy sitting next to me, right? I'm out. I'm overwhelmed.
Yeah.
The guy says, "Okay, I'm a trainer. I'm your coach. Okay, I'm going to deal with this situation. Maybe I cannot save you 100% time, but if I save your ass 99% time, that is good enough, right?"
No, it's understood. I get the signs from over there that although I thought we have unlimited time, they said we have to close more or less, and we are just in time, 4 o'clock. So thank you. Thank you very much for being here, and sorry for that you're on the last. Again, I will try to put you in next. Yeah, but right. What would a human do? The thing is, thank you, and I think this is really a subject we have to continue, and we have to continue, I think, in every single aviation event in the future, because I think it's a core issue. Otherwise, there will be no low altitude economy. That's what I'm persuaded of. Okay, so thank you very much.
好，咱们那个整个会议的议程就完满结束。下面
If we are now concluding and the sessions in the forum, now let's welcome Mr. Chen to do the conclusion. Closing remark.
来吧，可以，咱们算一个 team。
我们那个整个一小团队啊，那个Willi 是我们外方的召集者。
We are a team. Willi is the organizer from the foreign part, and Mr. Gao for 9 years in a row as the moderator for this forum.
那个我先 my first。
Yes.
Yeah. Okay. 今年说实在是第9年，我们觉得也是。
It is the 9th year, and I have quite like deep affection about this forum, and we witnessed the growth of China's low-altitude economy, just for companies like e-flight. Since the first forum, Mr. Tian Yu, each forum he attended, we can see from 2017 up till now. Now, e-flight is already the leader in eVTOL. We witnessed his growth, so I want to thank everybody.
First of all, we'd like to thank all the speakers. Thank you so much for taking time out of your busy schedule and for being part of the forum, sharing with us the latest information and the most cutting-edge technologies, as well as practical applications. Thank you very much for your trust. On September 29th, we just opened the participation channel, and we already have people applying for next year's forum. We would also like to thank Kunshan government's support, because without them we wouldn't be able to have enough funding to have this forum. I'd like to thank Mr. Gao. We'd like to thank all the partner organizations and all the participants. We'd like to thank the hotel and the working committee. They started their work actually late at night, 11 p.m., and everything is in perfect order. And simultaneous interpreters have been supporting us over the years. Their precise translation have greatly supported the forum. We'd like to thank these 2 interpreters, and we look forward to working with you next year. Also, I'd like to thank people in the room and people who have left the room. We do not major in event holding, so we just help with organizing this forum in our spare time. So thank you so much for sacrifice. Also, we've got some some of those items didn't come across as we have expected because of some policy changes. Thank you for your understanding. Next year would be our 10th e-flight forum, so I look forward to seeing you next year, and I hope we could see new progress and new achievements every year. Mr. Li presented new things every year in the last 3 years, and we look forward to hearing the good news every year. We all want to witness the annual progress, and we all want to be part of the common progress.
Because I was speaking enough over the last days. So thank you, Patty Jen. Thank you, the whole team. I think we've done a great work, and that's also in the days and the weeks and the months before, we always have sometimes disagreements and agreements, which comes because we want to do the best. And if you want to do the best, you have a different opinion, you have to fight for what you want. So I think we look at the result, the forum is growing from year to year, and we have a lot of top speakers in the industry which come back every year. We have more industry coming, and when we see like somebody like Tian is putting his event in front of our event on the day before.
For example,
Mr. Cai Wenkuan first heard of our forum in 2017, and then he made up his mind, resigned from his previous company, and then started his own company. So I'm quite honored to hear that, and I'm quite happy to see his personal progress.
Travel from far, like having guests like Scott and Margaret, or Margaret and Scott, should be gentlemen, from United States traveling over in the week of Thanksgiving. Thank you very much for this. And or from Australia, we have really people from everywhere, which shows that the people appreciate the know-how which we can transfer here and our common sense. We want to work together in aviation. We think aviation is a global thing, and we have to work together with it. And with this, thank you very much again being here, and see you next year, and maybe at the Aero in Friedrichshafen in Germany.
好，谢谢，应该是那个。